Hello everyone and a very good morning to all of you. Ladies and gentlemen, I'm very thankful to all of you for joining us in the webinar on promotion of light electric vehicles in SAARC. My name is Muhammad Umar Mukhtar and I am working at SAARC Energy Center as a research fellow in energy, transport and environment portfolios. I shall be moderating today's SAARC webinar, the aim of which is to highlight and promote the numerous benefits that the use of light electric vehicles brings to the common consumer and the governments, and disseminate the information among the policymakers, regulators, researchers, academia members, and other stakeholders from the SAARC member states. Ladies and gentlemen, two-wheelers provide accessibility benefits over cars and public transport. Especially in dense cities in Asia and Europe, bicycles and motorcycles are more affordable, flexible, reliable, and often faster than cars. In addition to reduced space requirement for parking, motorcycles use 3.5 times less road space than cars. Two-wheelers are thereby much more space efficient than other private vehicles, even when considering a slightly higher average occupancy rate for cars. The environmental benefits are substantial as well, in particular for climate change, air quality, and noise. Compared to conventional motorcycles, electric two-wheelers emit substantially less carbon dioxide emissions per kilometer on a life cycle basis, even when powered by coal-based electricity. Indeed, over 80% of the 29 million tons of CO2 savings in 2017 by all types of electric vehicles globally are due to e-bikes in China alone. However, two-wheelers, including electric two-wheelers, suffer from a bad reputation and a lack of attention from policymakers in many countries. Other than China, e-bikes and electric scooters are still in an early adoption stage, and through this webinar, we would like to discuss some of these issues. The participants of today's webinar are from relevant government departments, research organizations, academia, associated industry, and private sector, specifically from South Asia. It is my pleasure to inform you that Dr. Shoaib Ahmed, who is the Deputy Director of SAARC Energy Center, has also joined us in this webinar. We are very thankful to you, sir, for taking up time from your busy schedule to attend this event. I'm also extremely grateful to our panel of presenters. We are joined today by Mr. Sudhasatta Kundu from India Smart Grid Forum, Mr. Hemal Thakkar from Chrysler Research India, Ms. Arina Anisi from IRENA Germany, and Mr. Gul Hassan Bhutto from Pakistan. I thank all of them for their willingness and enthusiasm to participate in our webinar. I shall introduce them in greater detail before the start of their relevant sessions. Now, I would like to request Dr. Shoaib Ahmed, Deputy Director, SAARC Energy Center, to deliver his welcome note.
Well, thank you, Umar. Dear participants, presenters of the webinar, friends and colleagues, Assalamu alaikum and very good morning. I, on behalf of SAARC Energy Center, welcome you all to this webinar on promotion of light electric vehicles in SAARC. It's a great honor for me to open the discussion on this important topic for the development and for prosperity of the people of the region. Dear participants, the SAARC Energy Center is a regional institute on energy and technical arm of SAARC organization on energy matters. It is our endeavor to transform the energy vision of SAARC leadership into reality. The center started its operation in year 2008. During last 10 years, the center has emerged as a vibrant and effective SAARC institute, which has played its role in all regional level energy initiatives. Until last year, the center has carried out 150 plus interventions. The reports of all these interventions are freely available on center's website. Dear participants, conventional internal combustion engine vehicles emit pollutants like carbon dioxide, carbon monoxide, oxides of nitrogen, and particulate matter, thus contributing to their high ambient concentration in urban areas. Exposure to these pollutants in significant concentration is known to cause severe damage to the health of the people. The urban poor are particularly vulnerable as many of them live close to the roads where these vehicles operate in large numbers. Each year, air pollution accounts for tens of thousands of premature deaths and billions of dollars in medical costs and lost productivity. The large number of two and three wheelers, particularly in large cities, contribute significantly to urban air pollution. Dear participants, electric vehicles with zero tailpipe emissions have a great potential for reducing this pollution. However, electric cars are still relatively expensive, especially in the context of purchasing power of the consumers in the SAARC member states. However, there is a good potential for the electrification of road transport, particularly in urban areas, through light electric vehicles such as e-bikes, e-scooters, e-motorcycles, and e-rickshaws. Through this webinar, the aim is to highlight and promote the numerous benefits of the use of light electric vehicles to the common consumers and the governments. Dear participants, in this webinar, we have invited experts from the SAARC region and beyond. I am delighted to acknowledge the great cooperation and support extended by them. In the end, I once again thank you all for joining this webinar and shall request you to feel free in expressing your opinion. I would like to extend my special thanks to the presenters of the webinar. Lastly, I wish you all a very comfortable learning and knowledge sharing session. With these words, I declare the session open. Now I request Mr. Umar Mukhtar to take us through the agenda of the webinar. Thank you.
Thank you very much, sir, for your welcome note and explaining the role of SAARC Energy Center. So now we'll be moving on towards our presentation session. Our first expert, Mr. Sudhasatta Kundu, is currently working as Senior Manager Technical Advisory in India Smart Grid Forum, and he has an experience of over 10 years in the energy sector. He is an electrical engineer and an MBA in power management. He has worked with various power and transport utilities, multilateral and bilateral agencies across South and Southeast Asia, such as in the countries of Nepal, Bhutan, Bangladesh, Laos, and Indonesia, on development of electric vehicle implementation roadmap. He has also worked on EV charging business models, smart grid roadmaps, policy and regulatory assessments, energy security, cross-border power trading, and also co-authored various publications on EV charging infrastructure, smart metering, hydropower development. Mr. Kundu will be giving a presentation on charging strategy and implementation of EVs. Dear participants, before I hand over the control to Mr. Kundu, I would like to inform you that you can have the opportunity to ask questions to presenters by typing your questions or clicking to the raised hand option into the attendees panel of the main window of GoToWebinar software. You may send in your questions at any time during the presentations, and we will collect these and address them during the Q&A session at the end of each presentation. So now I hand over the control to Mr. Kundu.
Thank you, Mr. Umar. A very good morning to all of you. And thank you very much, SAARC Energy Center, for giving me this opportunity. And as you introduced me, I am Sudhasatta Kundu. I'm working as Senior Manager Technical Advisory from India Smart Grid Forum. And I'll be presenting on the topic charging strategy and implementation for the light electric vehicles. As an organization, I'll just first describe my organizations a bit. It's a public-private partnership initiative of Ministry of Power of Government of India, and which is responsible mostly for the accelerated development of smart grid technologies in the Indian power sector. And we are also involved in various activities in the EV domain, from implementation roadmap, development of implementation roadmap to the charging standards with the Bureau of Indian Standard Organization. And we have 200 plus members comprising of ministries, universities, academia, research, who are currently our member and provide various inputs. And we also provide various inputs for development of those organizations, as well as we give policy inputs or regulatory inputs to the government of India. We world as a think tank of global repute, because on smart grid and smart cities, as we are not only working in India, we are working on various countries other than India, like in Bhutan, and we have already worked with SAARC Energy Center for various projects on smart grid and EV, and we are also working in Indonesia on the smart grid and EV domain. I'll just describe something, some projects that we did on the electric vehicle. That the key projects that we did on electric mobility and from India Smart Grid Forum. One is we did the establishment of charging infrastructure for deployment of electric buses in Kolkata. In this project, we helped the West Bengal Transport Corporation, the utility, the transport utility in the state of West Bengal in India, from the stage of development of the strategy for implementation roadmap for electrification of public transportation, including all the buses, the four-wheelers, the three-wheelers.
Excuse me, Mr. Kundu. I think there is some voice distortion from your
And
side.
also we worked on the water transport side, and then we developed, actually we helped the planning of supply. Now it's fine. Hello.
Yeah. Now you can go ahead.
Hello.
Yes. Please continue now. Now you are audible.
Right. For the planning of electric vehicle charging infrastructure in the Bangalore city, where we are doing load flow study of the grid and also assessing the inputs, what will the infusion of the electric vehicles, mainly two-wheelers and three-wheelers, and also the four-wheelers, for placing of the charging stations, for identifying the location along with the location of the grid, the nearest substation, because the municipal charges and other charges that are associated with drawing of the lines to the public charging stations from the grid is very costly in India in some of the cities, in the major cities actually. So we are doing this. We also did a study on the study of infrastructure enabling environment for road electric transport, where we provided the recommendation for taking up of EV, how to accelerate the deployment of EV in the SAARC countries, all the 8 SAARC countries. We did implementation roadmap for electrification of public transportation in Kolkata, which I mentioned before. We are also doing a feasibility study on introducing electric vehicle in Indian Sundarbans, which will be most relevant to this webinar, because in this we have because in Sundarban is a global eco region, which is where currently only the use of what you call engine vans, using of diesel and kerosene in the engine, and people are using those engine vans for local transportation. And now with the introduction of electric vehicle, the carbon emission that will be reduced will be huge on that. And we are also doing a business model for developing for using those electric rickshaws, and also putting up street lights with solar and storage, and using those street lights for charging of the electric rickshaws. Then another, we did the preparation RFP and operator agreement for the procurement of electric buses under FAME 2 for West Bengal Transport Corporation, which is currently the FAME 2 is going on an OPEX model, where the transport utility will be providing the depot and everything, and the operator will operate the buses for a certain period of time. Then we also did the study of smart grid and electric vehicle market scenario in India. It's a NEDO project, NEDO Japan project. Did what is the market assessment. Then we also authored various white papers on electric vehicle charging station business models for India, a study report on the electric vehicle policies and electric tariff for EV charging in India. Now, which should come first? That's it's a very pertinent question. Whether the charging station should come or whether electric vehicle should come first. But if you see, when talking of only the two-wheelers or three-wheelers, always there is a range anxiety for the consumers. Right, but the consumers, suppose for anything, if you want to accelerate the deployment, the normal people or the citizens of the charging. But there is another question: is that if the charging station is there, then how the return on investment will be carried out? How the return on investment will be justified for the investors? Because if the number of electric vehicles are very less, then the charging stations or the charging station operators will not earn such amount of money to get their return on investment on time. So there are various push factors for this charging stations to come up, like consumer preference, the electrical network requirement, the charging tariff, because the charging tariff that will also drive your acceptability of the electric vehicle. Because if the charging tariff in some of the states in India which have not come up with electric vehicle policy, a very high charging tariff includes the demand charge and the energy charge. So in that case, in the demand charge and energy charge, if the demand charge is in some of the states where policy is there, demand charge has been waived off, and the energy charge has also been reduced. But when it is coming up, like in Calcutta only, when the buses are getting charged, the demand charge and energy charge, they're coming out at 15 rupees per unit, which is very high. Then the electric network then electric network availability and the near to the electric network, the public charging stations should come up. And the major thing is that if every household, there is a case in England, if every house in London especially, if every household having an electric vehicle and they put the charging station in their house and it is connected to one phase, then there is a phase imbalance. Right. So we also need the grid modeling studies to develop those when you are expecting the two-wheelers to come up in the homes, and then we need to do a proper load modeling studies to understand that whether this charging station should come up and in which phase, because there should not be any phase imbalance, because that will impact on voltage and power quality. Then the charging station development are the key drivers. Now the first of the drivers that should come up is the policy and standard. Every state in India or every country and every state in the country should have separate policy and standard depending upon the needs. It's not that every state, suppose if there are states in Pakistan which can have the same policy, or provinces in Pakistan which can have the same policy, because the infusion of the electric vehicle in Islamabad will be different for the infusion of electric vehicles in other cities, smaller cities. So policy and standards that should be developed. Standards should be taken up from international if you don't have the capability to develop national standards. If also national standards, because standards take time to develop. And if you want to develop their own standards, is fine, but you need to take guidance from the international standards, like in DC charging, there are CHAdeMO, CCS, and not only the fast charging standards, you have to adopt the communication protocols also, like Open Charge Point Protocol and others. Second is the EV penetration. Charging infrastructure development or public charging stations should be different for different cities based on the EV penetration. In somewhere the two-wheelers or somewhere the three-wheelers will be high, because in many cities in India, the three-wheelers are moving from point to point. In some cities, the three-wheelers in Delhi, like three-wheelers are moving all around the city. One three-wheeler can go from this point to the end point to end point. So there are various types of movement of the route planning, and everything should be done and understand and got the EV penetration done, so that this will help to develop the charging infrastructure. Second is the location. You cannot put a public charging station location far from the grid. This will increase your cost heavily. You cannot put your charging station location far from the, what you call this, EV zone, or the EV has come up. You cannot put the charging station far from that. That will also reduce the ROI. Then the grid upgradation charges. Suppose in a home there are 5-6. Suppose currently we are normally living in an apartment or living in a builder flat. So in the builder flat, there are various constraints on the charging space, and you cannot go everywhere and put a charging station on the wall of the garage or everywhere. So for that we need to, and if there is a charging station, if the rating of the charger is very high, then you have to, because in India there are some of the states 7 kilowatt is a single phase. You need to move to 3 phase for upgrade your capacity. Now, if you have a charging station of 7 to 8 kilowatts, more than the 7 kilowatt allowed, then you have to go to 3 phase. That will increase your charges. Again, the demand charge will also increase. That also matters. Then the battery characteristic of EV. Currently, all the batteries that are in the market are either C or C by 2. That means whatever your charger capacity is, the battery cannot charge. Suppose not more than the C or C by 2 charge rate. Suppose there is a 10 kilowatt charger or 7 kilowatt charger, and you have the 7 kilowatt battery in case of three-wheelers or e-autos. Then when you are doing a e-auto, charging an e-auto, the 7 kilowatt charger will charge a 7 kilowatt hour battery in 1 hour only. You cannot make it in 15 minutes or 10 minutes, the full charge of the battery, because the charge rate is not even more than 3. C. The C is the charge rate, or in some cases it is C by 2 also, that it take 2 hours to charge a 7 kilowatt hour battery for 7 kilowatt charger. Then the charging time. For the charging infrastructure development, the charging operator, to get that, the charging time is very crucial, because the first they charge, the more they get the revenue. But the charging time will also depend on the battery characteristic of EV. Then the charging tariff, as I told before, the demand charge and energy charge whether should be reduced, or the demand charge should be waived off, should be left to the utilities, and should decide whether this how the charging tariff should be done, so that the people can buy electric vehicle and with a less operating cost. The service fee of the charging operator should be given right now a push, because without the service fee, there is increase in service fee. The charging operator will not be able to get their ROI, because that is the only source of revenue on them. Because without the development of more number of, without the deployment of more number of electric vehicle, the retail stores or some service centers or other things around the public charging station is not feasible economically right now. And the major question will be that there are too many stakeholders. Revenue already I've talked about of the charging station, the charging tariff and the service fee. And the too many stakeholders, there are municipal corporation involved for the land, there are other builders will be involved for the land, and how to align them and to achieve the objective of accelerate the deployment of electric vehicles. That will be one of the major what is the major criteria for the setting up a charging infrastructure development. There are various government initiatives that India has taken, and there is the charger connectors that has already been given by India as a for the public charging station operator. And some PCS, if they need to come, they have the option of these chargers, where they have to put this either one of the fast charger and the two of the slow chargers in every public charging station. Like there are currently India under the FAME2 has given 2636 charging stations in 62 cities. That's the DHA has given subsidy for the charging stations and selected various operators, mainly the government operators like NTPC, REIL, Rajasthan Electronics India Limited, and the ESL Energy Efficiency Service Limited. 14 states have EV policies and more than 13 states have special EV tariff for EV charging. So these states have given, some of the states have waived off the demand charge, some of them have reduced the energy charge, and some of them have given a flat rate for the charging of the EV. And if you have seen on the charging stations, there are every 100 kilometers on each side of the highways, and that is also a step taken by Government of India. 20% parking space for EV charging. Now all these things are given by India, means the government taken initiative taken by the Government of India for to motivate the investors to invest more in the charging public charging stations or some of the charging stations, so that the people also buy this electric vehicle charging stations and put up those. But there are various points that India that current market should think of. Not only in India, in the most of the South Asian countries, the thing is that if without the development or without the means infusion of much of the electric vehicle, the main point will be the ROI of the PCS, because public charging stations, if they don't get the ROI in sometimes, because on the next 2 or 3 years, it will be a dead investment for them. Now, when you're looking at this, the best business model that India or any other country in the Southeast Asia can think of is one of the utility-based business model. But the utility can own the charging stations and pay for the charging stations, because they have various substations, there are various points where they know where the grid is, and they can very easily establish those charging stations near to the grid without any problem with the location or the land acquisition, and can give the operator to provide for the and give the operator to operate those charging stations. And it will be very easy for the operator of charging stations, because they will give the service fee, and the utility, if reduce the demand charge also, they can pass on the capex of those charging stations in the tariff to the consumer, And if in one of the utility in India, we studied that if some is not 100, it's more than 200 or 300 charging stations are put in a city, on the nearby cities and the nearby. And if those charging stations, the capex of the charging station has been passed on to the consumer through tariff, there is hardly 1 paisa, 2 paisa increase in the tariff, which will not be a problem. Similarly, for highways, when you're constructing a highway, we can put the charging stations beside the highways, and you can inbuild the capex in the highway cost, and that can be included in the toll. So that will be hardly a very few paisa. So that will not be a problem for the consumers also to bear that amount, and it will be a win-win situation for both the side, and utility also will get their revenue. And apart from that, this utility will recover their cost, and the public charging station operator can get the revenue. So there are a few of the charging standards, like the combined charging system (CCS) that India is, and there are a few standards like CCS mostly used in Europe. CHAdeMO or Charge de Move is mostly used by the Japanese cars, and this because this is developed by the Japanese consortium. And the second is the Type 2 AC, minimum 22 kilowatt. This is AC charger. The first, the above two are the DC chargers, and the slow moderate chargers. These are the Bharat chargers developed by India. This Bharat DC 001, Bharat AC 001. The point is that India is currently developing its own standards, which will allow the CCS and the CHAdeMO both, because most of the cars are the European make or the Japanese make. So we need to allow the CCS and CHAdeMO so that every car in India, the electric car which you got, there is no problem in getting in charge, or there is no problem in the plug and play system. So these are normally given by Government of India, the charging standards, and this is the minimum 50 kilowatt is set up by the Ministry of Power, the 50 kilowatt on this for the fast chargers, and these slow chargers, the 15, 15, 10 kilowatts for the slow chargers. Mostly the two-wheelers and three-wheelers, and we'll be using this Bharat AC charger or Bharat DC chargers, right? And normally the two-wheelers or three-wheelers range, the battery is from the 3 kilowatt hour to 7 kilowatt hour to from two-wheelers to e-auto. And normally they, for the three-wheelers, normally 2 kilowatt chargers are there, and for three-wheelers also 5 kilowatt chargers are there. It's for the 3 kilowatt, it's 1 to 2 kilowatt charger, and for the two-wheelers there are 5 kilowatt charger, 3 to 5 kilowatt charger are also available in the market right now. But the best business model will be that in Calcutta, also in Newtown, but we see that the people with having the e-auto, so that they don't go anywhere else for charging and they don't waste their time. There is a auto stand, or this is called this location, or the autos queued up for taking up the passengers. And the point is that there are various street lights in those areas, so I put the sockets in the street lights and can easily charge their e-rickshaws when waiting for the passengers to come. So this gives the situation that no wastage of time is also there. This gives them motivation that where you stand, you can have a charging point, and you don't have to worry for the whether the battery is there or battery is dead, or what will be the SOC of the battery in any case. So that is possible because in Calcutta there is a point-to-point movement of the e-rickshaws. But when you talk about some of the in Delhi city where the e-rickshaws can move all over the city, then it will be slightly difficult to put a charging stations location specifically for the e-rickshaws to come. And secondly, for the two-wheelers, now two-wheelers are mostly owned by homes, but if you see with the, as I told, these builder flats and the apartments are coming up, you cannot put it on everywhere in the world. So for the two-wheelers, it will be better somewhere this public charging stations or this type of charging facilities is there, where they can do up. All the societies with there's a 20% parking space for EV charging. They can put up some of the two-wheelers in that, but it will be mostly difficult in case of the uh, builder flats. But this type of facility is not there. This amount of space is not available. And also with this EV charging thing on the two-wheelers, with the individual homes also come up with that, then there's a phase imbalance and other problems may arise, which utility need to take care of through grid modeling and load flow studies, which are doing currently in Bangalore for setting up the charging stations. Now, some of the EVSE planning tips: the right location, choosing the right location to minimize the capex, right? The grid upgrades, maximizing revenue, the minimum land cost, the expansion capabilities. And the thing is that in some of the, if you put up a public charging station, the right location, which I discussed before, like choosing the right location means where the charging station need to be put up, whether near to the grid, it will reduce your cost, right? Whether the grid upgrade is required or not, because in Calcutta we studied there are various places in Calcutta, the existing transformers have the available capacity during certain period of time. So we can, through time of day tariff or time of use tariff, if that is being applied in some of the states or in some countries, then we can shift those demands in those period of time to utilize those available capacity in the existing transformer. Otherwise, you have to put a new transformer, new 11 kV line, which is costly. Then there is the maximize revenue, the minimum land cost, and the real estate issue. And when you put up in Pakistan, Nepal, and there are various, like, land acquisition will be a major problem in the major cities, because you need, when you're doing a public charging station, because currently in petrol pumps the consumer has the mentality that will go and there will 5 or 10 minutes of maximum 5 minutes you have to wait, or 10 minutes you have to wait. But in public charging stations, they can't need to wait for minimum 15 to 20 minutes during the day to get it SOC charged to a certain level so that he can move the certain amount of distance. Now, that land cost need to be reduced by finding a suitable land near to the grid. But the expansion capabilities, the area that you got, should be like that. Now you are putting up 3 or 5 charging stations, but in future you need to have the area to expand those capabilities, or you can put up a retail store or anything groceries or anything, so that the people who are coming up there and putting up the EVs for charging can what you call can spend their time in those facilities, and that will also become an additional source of revenue for the operator. Then is the right sizing, choosing the correct size of EVSE aligned with the charging needs and the battery of the EVs in the region. Like suppose you are doing a two-wheeler and three-wheeler, you know the three-wheeler in the city is moved from point to point, so the certain distance they will move. So there is no need of using a larger battery and increasing the cost and increasing the vehicle weight. Suppose in Calcutta or any other city, a three-wheeler move from point A to point B, not over the whole city. So why put a very large battery or 7 kilowatt battery? You can put a 2 or 3 kilowatt battery, understanding that okay, this knowing that this distance the three-wheeler will move, that will help them to reduce the cost of the vehicle also. That will help them to reduce the cost of the weight of the vehicle also, the weight of the vehicle and the cost, both. And that will be aligned to the charging needs. Suppose I am making every day, I am making, because most of the three-wheelers who are traveling or two-wheelers who knows that I'll go from here to the office or office to any other place, they know that this amount of charge I require, this amount of distance I'll move. So they can align the charging needs according to the tariff system also, and they can align the charging needs according so that they have to pay less, and they have to spend minimum time in the charging stations. And also the batteries of the EVs in the region, because the battery charging rate also differs, because CY2 and C is already the charge rate that is available in the market. Lithium titanium oxide battery that come to the 8C or something, that is not commercially viable right now. And the planning studies need to conduct detailed modeling studies on the grid before granting new connection to bus depots or public charging station. And even in the home charging, this need to be taken care of, because in the same phase, if all the chargers are connected, there will be a problem in the phase imbalance. And also, if proper load modeling studies are not done, this phase imbalance about the power quality and the voltage will, the quality of the voltage and power quality will degrade, and that will hamper the charging. And also, if there are rooftop solars that are coming up in most of the countries in the SAARC region, rooftop solars are coming up. If you put in the rooftop solars and the charging stations or the chargers in the same feeder, it will help this utility to manage the proper flow of power in that. So that, because renewable is also intermittent and EVs, and they can counter each other, and they can maintain the proper power quality. And the right business model, utility-owned charging station, that we normally what you normally propose, that the fleet operators, the PSUs are bundling with toll, that I told you, the tariff or toll in the highways, we can put that. Then provision for ancillary services, the provision for ancillary services will be, glad to know that OCPP, and most of people may know that OCPP, that is the Open Charge Point Protocol, which is the communication protocol from charger to the back end, as a facility given to the balancing the grid. If you can balance the load, not the grid, you can balance the load of the charging station. You can modulate the charger according to the load required. So that will help them to find the right business model also in some of the cities. So this is the my presentation on that, and I can just share you some of the EVSE standards in India as of now. What is the progress in that? That is IS 17017 series of standards, primarily based on. You can see the description. This is nothing to explain, because we are in the process of development, and ISGF is working with Bureau of Indian Standards in developing those charging standards. But DC, EVSE, and EV, the draft to be finalized and all that. So these are the stages that we are in. Even in the, you can say, IS 17017 part 3, the sections 1 to 7 reserved for light electric vehicle standards by panel 2. So that is, we are also developing the standards for the light electric vehicles also. So with this, I end my presentation. If there are any questions, I'll be happy to take. Over to Mr. Umar.
Thank you so much, Mr. Kundu, for your very comprehensive presentation on the charging strategies. We have got quite a few questions here, so we'll quickly go to those questions. The first question is from Mr. Jawad Sahibzada from Pakistan. It's a long question. He says that he has an electric vehicle startup, and he's a team lead of that startup. He mentions that he has developed a prototype, but he's having problems regarding motor controller and can't find the equipment here locally in Pakistan. So he has mentioned that we need a platform where new tech startups can get support in developing new electric vehicles, and the imports from India should be easier because India is far ahead in terms of technology and product availability. So he's just asking, is it possible to work together towards electrification and introducing a common platform where the tech startups could collaborate between the two countries? He's just like, maybe if you would like to answer this question. I don't know if how
Sure,
related.
sure, sure. No, actually, ISGF can help that, and we will be possibly it will be better to help through SAARC Energy Center if someone is doing that. We can provide the platform also. So we can I will share my details with him, and when the details are with you also, you can share. And if they can reach me out for this, and we can discuss it offline also how to go about that. And we can take SAARC Energy Center also in loop for facilitating those access to the local market and all.
Perfect. So for Mr. Jawad, we would share the presentation and the contact details of Mr. Kundu on our website. You could write to us, and we would help. We would be glad to help you out, and in cross exchange of knowledge. His next question is that basically he's having difficulty in developing the drivetrain. So I'm sure once we connect you with Mr. Kundu, you could have detailed discussions with him regarding your exact problem, and he would be, as he mentioned, he would be glad to help you out. So we have another question from Mr. Ayush Anand. He mentions that in policies for charging infrastructure development drivers, do you foresee using renewable energy sources, mostly solar PV, being incorporated similar to open access model for supplying power to charging stations?
Means open access model can be used, but when you could come to the utilities, means I can you just frame the question? Can you just tell me the question again, because I didn't get the question with renewable energy and open access. What he wants to say?
Yeah. So he writes, in policies for charging infrastructure development drivers, do you foresee using renewable energy sources, mostly PV, being incorporated similar to open access model for supplying power to charging stations?
Yeah, renewable energy when you are integrated into the grid, because open access is like that in India or any other countries. If open access is there, the open access will be the platform like you can procure power from anywhere in any parts of India. But when you are bundling those PVs and others in the grid, there is a grid connected PV or the solar mounted PVs. This mounted grid means ground mounted PVs or solar PVs, that when you are integrated into the grid, that power, then you don't have that I have a solar power or something like that, right? Because you have to purchase, because nothing is that you can buy a renewable power. What you have is that you have a renewable purchase obligation for different utilities or for various major industries, right? So for that, you can open access. Obviously, in distribution, we're trying to do that. All the public charging stations may come up with solar. In Calcutta, also we assessed a commercial and technical both viability for a bus depot where we put the solar to cater some of the parts of the charge load. So that is possible, but not with the renewable energy specifically, until there is a policy thing that come up saying that you need to procure power directly through renewables for the charging. Otherwise, the power will be mixed and you can procure power through open access. But in India, currently, when you are going for, if you are thinking of a utility business models, then obviously you can think of that, because the utility has already a mandatory RPO is there, renewable purchase obligation is there. Utility can show that with this renewable purchase, I am providing the power to the charging.
All right, sir. So,
Mr. Omar, this is my answer.
Yeah, thank you so much.
Hello.
We have next question from Mr. Sudhanshu Mishra. He is from GIZ India, and he mentions that GIZ India has concluded a study to understand the impact assessment of large-scale integration of charging infrastructure. He thinks that the content and methodology will help the ongoing study for Bangalore city. He basically wants to get in touch with you. So for Mr. Sudhanshu Mishra, sure, we will share the contact details of Mr. Kundu on our website. The presentation would also be uploaded. I will request Mr. Kundu to share your details on the presentation, the first slide of the presentation. So if anyone who wants to get in touch with you, they can get the required information.
Then sure, because we are already in touch with GIZ, the team lead in EV. I think Mr. Indradeep Mitra is already, we are very known to him, and he's also very known to us. So it will not be a problem to share with GIZ any details and any help we require. Currently, we are doing the load flow studies with the software using a tool that we can discuss offline also. Thank you.
Perfect. Perfect. We have one question from Syed Zohaib Ahmed. He mentions that we are focused on first order benefits of electric vehicles, but no policy covers the end of life recycling of electric vehicles. So how does India plans to handle this thing?
See, the end of life of recycling of electric vehicles, obviously not. But I think his question must be on the battery, recycling of battery.
Yeah, I guess so. Yeah.
Right. That's the recycling of battery. I think some 1 or 2 weeks back, there is a battery waste management rules have come up already in India. So you can go through that. What kind of battery for every kind of lithium and batteries and others that battery management battery waste management rules have come up. India is not thinking not that that is not means right actually, because some of the companies like Tata Chemicals have already started doing recycling of batteries. That already started everything putting in place, and all the facilities are putting in place by Tata Chemicals to start the recycling of batteries. And there are various companies are also coming up in India for that recycling of batteries. Obviously, it is at a nascent stage, I will say, that only 1 or 2 companies, that it will take time to grow. But we are thinking, and every country in SAARC member states should think of that, because it's not only a huge market, it's good for the environment also. It is required for the environment, not good for the environment, it's required for the environment also.
All right. We have one question from Bimal Gyawali. He mentions, will you please explain something about FAME 3 business model for public electric vehicles procurement? So if you could explain very briefly, because I'm sure it's a big subject.
Sir, it's not a FAME 3, it's FAME 2 actually. The FAME 2 has come up with a OPEX model. So like that, the government, DHI, that is the government, Department of Heavy Industries, and Government of India has provided subsidies to various utilities. Means ask them to submit a EOI or a proposal. For this minimum, the run should be about 5,000 kilometers per month. Then those utilities where the buses are running minimum 5,000 kilometers per month can apply for this proposal, and in various cities that they should apply. Based on that, they have given the subsidies to, they have chosen various cities and allocated certain number of buses, and for which a certain number of buses for which the subsidy will be given by the DHI. Now what is in the OPEX model? Now there is a model concession agreement already been available in the website or in the Google. Model concession agreement has been prepared for the operator, where the transport utility who is procuring the buses from the DHI and getting the subsidy will be giving the bus depots and the terminals. Will be given the bus depots, the terminals, or the location actually facilities to the operator. Operator will install charging stations and the buses and everything. The model is that the operator, during the bidding, to selection of the operator by the utility, during the bidding, the operator will provide a fixed rate per kilometer that they will charge from the transport utility, right? And in every bus, the conductor will be from the utility, so that the fare that is being collected is taken up by the utility. So there are the charging stations, the buses, the depot maintenance, and everything will be taken care by the grid. Everything with energy charge, everything will be paid by the operator. This transport utility will provide these facilities, and with that, and they will only get the fare of the customers. And and the operator will charge a fixed rate per kilometer from the utility. This is the model for certain period of time. The utility will come up with a bid. Every operator will bid for that, and the operator which has the lowest rate per kilometer charged to the utility will win the bid, and will develop all the facilities for this. I mean, if you are Mr. Umar, if people mostly you are people from the power sector also, you handle power also. So in India, if some of the people who knows the power sector, the competitive bidding, it is, I'm not saying mostly similar to that, but partly similar to that, because in that also the utility, the consumer tariff is getting, the utility get the consumer tariff, and the developer who is developing the power plant for supplying to those utilities, they charge a fixed rate per unit, right, based on which the bidding has been done. So this is more or less similar to that.
All right. Thank you so much. Now we have last 3 questions, and because we are short on time, so I would request you to quickly answer these 3 questions. The first question is from Mr. Kashish Shah. He asks that probably this question has already been answered in your previous answer, but you could expand more on it. He questions that regarding smart charging and coordination of EVs in future, who will be the responsible agency for smart coordination and load management, the aggregator or the utility? Hello, Mr. Kundu, can you hear me?
See, it will be from the back end. I think there's some problem with the network. Now it's fine.
Now I can hear you.
Hello. Hello.
Now I can hear you.
Yeah, right. Actually, when backend from the means overall management should be done by the right. Overall management should be done by the utility, but when the number of vehicles have come up, the vehicle aggregator can play a major role in certain points, at certain points or certain pockets, where they can do this vehicle aggregation for the load management and others. Because that also is load management and all this, when the vehicle aggregator's role will come up only when the most of the thing is on the smart charging, means vehicle to grid integration, what he or she wants to intend to mean to, I think. Vehicle to grid integration, when vehicle can feed power into the grid, right? So that can be done when that at that point of time, when that facility will be available and vehicle will be feeding power to the grid. That point of time, the vehicle aggregators will play a major role.
All right. We have a question from Mr. Saad Latif from Karachi Electric Corporation. He asked that how prevalent are battery swapping stations in India? Can you shed some light on this?
Yeah, battery swapping stations are prevalent in India. We are trying mostly for the three-wheelers, because three-wheelers have a specific design capacity, like ICAT approved bodies are there. So there you can do for the three-wheelers, but do that. But for buses, in one place in Gujarat, in Ahmedabad, the Sun Mobility and Ashok Leyland has done that. And because it is easy for them to do that, because there is a BRT, that is bus route again, special bus route are there, there are designated bus routes are there, that is called BRT. So for in that, the time taken is very low for the buses to move from one point to other point, because there is a designated route. So the battery capacity is used in those buses are very less. So it is easy for them to swap. In only one city that is there, but in many cities where the congestion is high, and when there is there is no specified bus routes. Specified means designated bus routes where no other vehicles will move in those routes. If those things are there, then only it can be done. Otherwise, in India, it's very difficult to do that. Your battery will replenish, because for swapping, the battery capacity might be less. It cannot be very high to move it very fast. It is to swipe it very fast.
All right. Now we have the final question of this session. This question is from Tola Podil. He asked that what is the maximum distance covered by existing electric vehicles? Probably he is asking in terms of two-wheelers and three-wheelers. So do you have any idea regarding in the context of India, what is the maximum range that you have been able to achieve?
The maximum average, if you can say, there are cities where people are going from per day, meaning 40 kilometers, right? There are cities where there are places also where they are going for 10 kilometers. And if you, because it's not about the two-wheelers.
I think he means in terms of the range of the vehicle, the capacity of the vehicle, maybe.
The capacity of the vehicles is that some of the vehicles has a capacity of 100 kilometers also. So it's not a problem.
Okay.
More than 100 kilometers also. So it's not a problem for that.
And for three-wheelers, the auto rickshaws?
Three-wheelers, I can say that they can 70, because they say much, but they can move out to 60, 70 kilometers.
All right. Perfect.
Batteries, because currently mostly they are using on the lead acid batteries. See, I am talking about the lead acid batteries because in India very few autos are there which are using the lithium.
Okay.
Lithium and battery, because e-rickshaws are coming up with mostly with lead acid batteries, which are trying to replace right now. But very few rickshaws are there, and e-autos are there which are coming off lithium. As Mahindra, if you want to know the exact, you can go to the Mahindra website and see. Mahindra e-autos are there which are running on lithium and batteries.
All right, sir. Well, thank you so much for your very comprehensive presentation, and then afterwards the detailed question answer session. Sir, we will be in touch with you. We'll be sharing your details with all our participants, and I hope that this cross exchange of information will be helpful to the participants. So once again, thank you so much for joining us in this webinar.
Okay, thank you everyone. Thank you, Mr. Director, and Mr. Umar, for giving me the opportunity. Thank you very much.
Thanks, sir. Dear participants, now we move on to our second presentation of the session. Our second speaker, Mr. Hemal Thakkar, is an Associate Director in Chrysler Research India. He has over 10 years of professional experience in executing assignments pertaining to automotive and logistics industry. His experience has been a mix of both consulting and industry. In his current role in customized research division at Chrysler, he leads a team of 20 plus professionals working on assignments across ports, logistics, and automotive sectors. His area of focus are identifying market potential, competitive benchmarking, traffic assessment, cost competitiveness, and regulatory aspects, to name a few. In addition to India, Mr. Hemal has worked on engagements in the UAE as well. The topic of Mr. Thakker's presentation is two-wheeler and three-wheeler electric vehicles demand projection in India. So with this, I would like to hand over the control to Mr. Hemal.
Yes.
Sir,
Yeah, so good afternoon. This is Hemal Thakkar, and thank you for the brief introduction, Omar. Can you guys hear me?
yes, we can hear you, sir.
And are you able to see the screen?
Yes, your screen is also visible. You can go ahead with your presentation, sir.
Fine, fine. Thank you very much. So good afternoon, everyone. The area that I'll be today covering is, two-wheeler and three-wheeler electric vehicle demand projection in India over the next couple of years. So basically, if you look at the title slide, it has three pictures. The reason to have this picture is to give you a differentiation in the kind of products that we are going to talk about today. So on the left-hand side of the screen, you have a e-auto, which is very common to a auto rickshaw that you see in any of our countries. The one on the extreme right is an electric two-wheeler, which is currently portrayed as an electric scooter. We also have an electric motorcycle in India, but I have put the photo of an electric scooter, so that's an e-two-wheeler. In between, there is an interesting vehicle which we term as e-rickshaws, and which has flooded the Indian market. Where we are having close to 2.5 million of such vehicles in India already, which are plying on various parts of the country. So just to kind of give you a sense of how a e-rickshaw looks like before getting into the presentation, I thought I should be having this slide. Once you move on to the next slide, what we'll be covering today is how the electric vehicle environment is. We'll be looking at how the FAME subsidy is, what are the PMP norms. So when I say PMP, it is phased manufacturing plan. A few requirements that the government of India has put forth for the manufacturers to register their vehicles who can claim subsidy under FAME. We'll also look at how affordability of vehicles is today and how is it expected to shape up going forward. We'll be looking at total cost of ownership, of owning a three-wheeler combustion engine versus three-wheeler electric vehicle. Similarly, two-wheeler combustion engine versus two-wheeler electric vehicle. And does it make sense to own a E3-wheeler and a E2-wheeler as of today? What is it that the customer is looking at, when you look at electric vehicles? What is his expectation? The various types of battery technologies that are there in India, and taking all these things into consideration, and the expertise that CRISIL has developed over a period of time in the electric vehicle space, how do we expect the EV market for two and three wheelers to shape up going forward? So today, if you look at the current EV penetration in India, you can clearly see that in two wheelers it is a very minuscule 0.06% of total sales. In three wheeler e-auto, it is around 0.14% of total sales. In case of e-rickshaws, we have 100%, which are electric. And as the previous presenter mentioned, most of it is lithium ion, lead acid. There are very, very minuscule, which is lithium ion. In the passenger vehicle space, we are at around 0.2% penetration, and in buses, we are at close to 1.2% of total sales. Now, if you see, with respect to penetration, we are fairly low or fairly insignificant for that matter. But yes, the government is making its efforts to ensure that, kind of EV penetration picks up in India because it's considered to be one of the cleanest fuels. Now, what we also see is if you go through this slide, what we've tried to do is the different kind of technologies that exist, with respect to battery technology. and the one that is the most preferred in India at this point of time. So lithium ion batteries are the ones which are the most preferred when we speak to people at large, which has an NMC combination. Currently, we are at 6:2 with respect to ratio of nickel, magnesium, and cobalt. Going forward, it may kind of change to a certain extent. There are also other battery technologies that are present in India, which are LCO and LFP. But then there is an issue with respect to the range that they provide and the battery life. So if you actually see, the battery cycle life is the highest for lithium ion, but even from a cost perspective, they'll be the highest. So we have a lot of batteries which are running on LCO, but they may not be as what one would expect in terms of the vehicle performance. But slowly, gradually, people are moving to NMC combination for lithium ion batteries. Also in this slide, if you see, what we've tried to say is, how the battery prices have moved, or how the battery pack prices have moved over a period of time. So in 2015, they were as close to or as high as $450, which are very much closer to around 200 odd dollars at this point of time, or 230 odd dollars per kilowatt hour. Now we are expecting this to further decline to around $150 per kilowatt hour and around 116 odd dollars per kilowatt hour by 2030. But what is important is this is fall in battery pack prices. But on the right hand side, what is also very important to see is how the specific energy is increasing. So what you mean by specific energy density is energy generated per unit. In very, very simple or non-technical terms, it is something to do with the productivity of the battery. So we are expecting significant improvement in terms of productivity, which is kind of depicted in the right hand side chart. And on the left hand side chart, you are also seeing that the prices of battery packs are coming down. So both this is a very good combination for electric vehicle penetration to pick up going forward. From an Indian scenario perspective, since the EV penetration will largely start increasing more from 23, 24 or 24, 25 onwards, we are expecting the battery prices to remain at around $150 per kilowatt hours in the 25 to 30 kind of period horizon. One major reason being economies of scale is something which will also dictate prices. So as you have demand, supply will follow accordingly. So we feel that demand supply dynamics is something which will keep the battery prices in check at around 150 odd dollars. We'll still be a little lower than what it is globally till that point of time. Frame one. Now, this is something that the government of India had come out with. This is called faster adoption and manufacturing of electric and hybrid vehicles. So the government of India had approved the National Electricity Mobility Mission Plan in 2013, and the plan was then unveiled in 2014. The scheme which the government of India came out with was from 1st of April 16. Was from 1st of April, 16 to 31st March 2018. India typically follows a year of 1st April to 31st March as its financial year, and they had a total outlay of close to 800 odd crores. If you look at the chart below on the left hand side, just one second. If you look at this chart here, you will see the total outlay was close to 800 odd crores. And on each of the buckets, that is tech platform, demand incentives, charging infrastructure, pilot, or kind of pilot operations. So they had split this budget in these parts. So if you look at the overall budget that was there, of which only 440 crores got utilized, that was 55%. But if you actually look at the utilization with respect to demand incentives, it was as high as 60%. If you look at the utilization with respect to pilot, it was close to 80%. Now on the right hand side, if you see, almost 2.5 lakh vehicles have claimed incentives under the scheme. Most of them were e-rickshaws and then two-wheelers. This scheme was further expanded for 1 year by adding 100 crores and taking the total outlay to 895 crores till 31st of March 2019. Now, despite that, the utilization levels were not very high, because what the government did is the government made some modifications to the scheme for the last 6 months. So e-rickshaws, which are largely lead acid, were getting this subsidy till then. And now e-rickshaws are, kind of not eligible for the subsidy if they are running on lead acid batteries. And if they are running on lithium ion batteries, they are eligible for this subsidy. So from that perspective, the volumes under FAME shrunk significantly in the last year or the penultimate year when, FAME 1 was happening. So the Department of Heavy Industries also modified the scheme to boost e-mobility in public transport, and they had received around 47 proposals from 44 cities, which was across 21 states. And there has been kind of requirement of around 3100 odd buses, around 2400 e four-wheeler taxis, and 21,500 e three-wheeler autos. And this is the supply, which was closed on 28th of February 2018. So this is something, which also was a part of Phase 1. Now, when we go to the next slide, what we have tried to do is the government has extended this program under FAME 2, which is started from 1st April 2019. So the government announced it on 1st March 2019, but the government, started to implement this program from 1st April 2019. Now, one huge difference that you see is the program size increased from 895 crores to 10,000 crores, which is a significant jump, more than a 12 time, jump, in the outlay that the government has done. So that also gives you a sense of the intent that the government has to, kind of push, electric vehicles. Also, what is very important to notice, the government came out with some riders to ensure that, we restrict our imports and the local industry flourishes. And also with the government's motive or aim of Make in India, which provides employment opportunities to a lot of people in the country, and which also provides basically what do you say, income generation opportunities for people, with incomes in their hand if they start working with either these startups or any of these manufacturing setups, and looking at the long term vision of India, where they would want to grow into a manufacturing powerhouse going forward. From that perspective, the government was pushing for localization. So for the qualifying criteria for these vehicles had become a little strict. So there was minimum 50% localization requirement for two-wheelers, and then the basic customs duty for a few components, which is low at this point of time, has been increased or is proposed to be increased for future date. There is expected to be a 3-year comprehensive battery warranty for the battery from the manufacturer. Now, this is extremely critical because today, when you look at combustion engine, the manufacturer typically gives 4 years and some few thousands of kilometers warranty for different kinds of vehicle. So, when the financier funds the vehicle, he is assured that the vehicle is technically sound, and he does not find much of a risk in funding that vehicle apart from the credit profile of the customer. So from a vehicle or asset perspective, there is not much, kind of risk that he sees. But with electric vehicles, the comfort with the financer was very low, and the financer was not extending that much support to the end user as in case of combustion engine. So this is something that, the government of India brought out as a rider. They also mandated, the vehicle being fitted with suitable monitoring devices to know mileage of vehicles. So most of these, kind of vehicles are fitted with very smart devices that you see or have on your smartphones. You can also track the performance of the vehicle, very easily. And private vehicles under two-wheelers to be allowed in this scheme. So except two-wheelers, the other all vehicles were to be used for public transport or for mass transportation. Two-wheelers were the only one, which were allowed under FAME 2, which was for personal transport. Now, as a part of the incentive structure for two-wheeler, this is going to support close to 10 lakh vehicles, the budget outlay. What do you say? The condition that they have is the battery size. For every 2 kilowatt hour, there is an incentive of around 10,000 rupees per kilowatt hour that they are providing. Now, maximum incentive will be 20% of the vehicle price, and maximum ex factory price to avail that incentive is 1.5 lakhs. So, which means 30,000 rupees is the kind of subsidy that the customer can avail as a part of FAME 2 incentives for two-wheelers. The total fund that is, kind of proposed for this by Government of India is 2,000 crores. Now, if you look at the difference in, kind of comparison between FAME 1 and FAME 2. Now, in FAME 2, the highest ceiling was 22,000, and which here has come to close to 3 lakh for, kind of under FAME 2. But if you look at the vehicle prices in India, largely by major manufacturers like Ather or the new iQube, which has been come out by TVS, or, even the likes of Bajaj Chetak. So there, if you see, their prices are anywhere in the range of 1 lakh to 1,20,000. So even considering that, and if you look at 20%, it is largely very similar to what you had in FAME 1. So the government has continued its, investment in this space. What is heartening to see is they are ready to support close to 10 lakh vehicles, which will help increase the penetration substantially. Also, if you look at the outlay, you can see that, between FAME 1 and FAME 2. So the above chart shows FAME 2 and the below chart is FAME 1. So for demand incentives has gone up from 500 crores to close to 8,500 crores. So there has been a 16 time increase, in the allotment for, demand incentives. Also, a lot of people have issues with respect to range anxiety. So earlier the outlay for charging infrastructure was 30 crores. Now they have expanded it to 1,000 crores. So they are trying to address both the areas by, kind of providing higher kind of funds to this particular space. And if you see, the total outlay is close to 10,000 odd crores. As I said, the government is having very, very, kind of high focus on localization because it provides employment opportunities and, incomes in the hands of individual at the end of India. And a country which is so dependent on employment opportunities for a people at large. So from that perspective, what they had said is they had come out with a phased manufacturing plan where they had mandated localization of certain parts to avail the subsidy that was provided for E2 wheelers, E3 wheelers, and E-passenger vehicles. Now, once the localization is, kind of met, then only they will be in a position to claim subsidy, or they will not be in a position to claim subsidy. So at that point of time, what they had said is, for example, if the lithium ion cells attract a 5% custom duty at this point of time. So this needs to be localized till April 2021. So basically, manufacturing of lithium ion cells needs to be done in India, and from 2021, that is 1st April 2021, the customs duty on this product will go high, which means that will discourage import, and that will, kind of encourage manufacturing. Similarly, entire battery pack which is currently being kind of given an incentive, and, the basic custom duty is as low as 5%, the custom duty is expected to go to 15% from 1st April 2021. So if you see in all these areas, the customs duty is increasing significantly, which also kind of gives a sense as to how serious the government is about localization. Also, if you see in Exhibit B, they have given dates by which part should be localized for e-rickshaw as well as e-auto. And if you see on the right hand side, the government, in the previous slide, as we discussed, there is a compulsory warranty to kind of qualify for FAME. So EV three-wheeler auto, they are giving a warranty of 3 years, 80,000 kilometers. E-rickshaw for 3 year, 40,000 kilometers, and e-two-wheeler 3 year, 20,000 kilometers. This also helps, the customers getting good funding for these products going forward. Now, we had done a short survey of, what does the customer really want from an electric vehicle. So if you see, we had tried to look at, various people in various age brackets. So we looked at metro city, say something like a Bombay or a Delhi, where, you have individuals in the age bracket of 25 to 30 years and also 35 to 45 years. And what we had looked at is a tier 1 city, where, somebody has, so a tier 1 city could be something like a Agra, or, something like a Nagpur, if you guys are familiar with those cities, where basically the income levels are greater than 5 lakh per annum. So when we look at the expectation, so speed is something, which was given top priority along with charging time. For example, if you see in Delhi, the charging time is anywhere in the range of 2 to 3 hours.
Excuse me, Mr. Hemel, we cannot hear you. Your voice is not audible. Uh,
Am I audible now?
yes, now you are audible.
Yeah. So when you look at the age bracket of 35 to 45 years, staying in a metro city, they would expect the maintenance cost to be the lowest. They would want the initial cost to be low. So that are the two top priorities. So if you actually see, people largely talk about the likes of range or charging infrastructure. If you look at the first category, that is 25 to 35 years, youth in the city, they are giving fourth priority to range and probably sixth priority to charging infrastructure. Similarly, in the second, range is third priority and charging infrastructure is fifth priority. Similarly, when you look at a tier one city, they are giving highest priority to charging time, then to speed, initial cost, maintenance. So basically, what we are trying to say is, yes, range anxiety is there, but contrary to the perception that people have, range is not the topmost requirement. Kind of that person has. But if you see, initial cost is something that features in the top three. Kind of. Priorities for all three customers, which means that there is some way or the other in which this initial cost difference between a combustion engine and an electric vehicle needs to be addressed. So what we also did is, we also checked with them, what is the kind of range that you expect or the kind of speed that you expect. So if you see, most of them said that, in metro cities who are in the age of 25 to 30, they required a range of around 70 to 125 kilometers. But as the age increases, you will see that, there are a few people who also require less than 70 kilometers, around 20% people. There are, if you look at, tier one city, again, there the requirement is for 70 to 125, and also a lot of people in the 125 to 175 kilometers, because once you are in a tier one city, a lot of things will be on the outskirts of the city, and hence the leads would be a little higher. On the other hand, if you look at charging time, about 80% people wanted it to be less than 2 hours. And if you see, this is largely the same, across all the geographies that we are looking at. Also, what we tried to understand from them is, in case if you have to pay a premium above your convention vehicle, to kind of buy a electric vehicle, because an electric vehicle will definitely be costlier as compared to your combustion vehicle. What is the quantum premium that you are, willing to pay, or you would, kind of want to pay? So if you see, there are a few people in the last two bracket which says, would not buy electric two wheeler even if all aspiration parameters are met, and would pay no premium. These are the kind of people who will not want to shift to a EV at all, at least in the near term, because they find the performance of the combustion engine vehicle very, very much better as compared to what an EV is. And also, they have built a perception that, in case if there is any issue with the combustion engine vehicle, we can get it repaired, or we can get it addressed very quickly, very soon, at a local or a nearby garage. But in case of EVs, it may be something more technical. So that's a perception that has got built into their minds. On the other hand, there are certain people, who are willing to pay some kind of premium. So around 20% premium is something that, 25% of the people whom we interacted with, kind of indicated, and 10% is what remaining 25 indicated. Similarly, if you look at the metro city in the age bracket of 35 to 45, 60% people say that why should I be paying any kind of premium? I will not pay any premium. And similarly, 20% people are across. You see, there is a difference in behavior. But if you see, there is still this category, which is larger, who does not want to pay premium. So if you see, initial cost is still a hindrance, which is again coming across very, very clearly in both the slides that we have tried to give. Uh, what is also very important to understand is, as I showed in the first slide, you would have seen that, the e-rickshaw sales in India had grown at a very, very fast pace. and we are looking at a current population of close to 2.4 million for e-rickshaws. Now, why is it that there was a sudden explosion in e-rickshaw sales? Now, if you see on the right hand side, unemployment is one thing that needs to be addressed very, very significantly. So there are a lot of people whose education qualifications are not that high. They would be hardly eighth or ninth pass or 10th pass, and for being for getting a auto permit, you actually require a basic educational qualification of being a eighth pass in India. Now, from that perspective, an e-rickshaw, there is no such parameter that is required, that you need to be an eighth pass. So, which also makes it very easy for anybody and any person who at this point of time is not educated and is not having any source of income. So, they can definitely buy a e-rickshaw and they can start earning from it. Also, what we've seen is, in some pockets in states like Uttar Pradesh and Haryana, there are a few females who are working as maids in a few households. But considering the people in South Asian countries, including the likes of India, Pakistan, Bangladesh, who fall under this bracket, there it is considered to be a social stigma if you kind of work at somebody's place. So for them, this provided a new employment opportunity. So they had come out with a new drive, Pinkathon, which was more like these ladies driving this e-rickshaws and kind of generating revenues out of it. Now, the reason for them doing well is they were low in terms of cost. Other good thing is the government of India had come out with a scheme which is called Mudra scheme, largely for to help the unemployed people in the rural side, where almost 50% of dealers have responded stating that Mudra loan has helped e-rickshaw sales, particularly from unemployed local and investor category. And also there were a few, financiers like Muthoot, Manapuram, etc., who used to finance the back of gold. So the people in the rural side would have some gold which they would keep as collateral and buy this e-rickshaws. So they were, generally in the range of 80,000 to 1,20,000 for a lead asset. A lithium ion would be slightly higher than 1,20,000. So because of this, the financing to a certain extent got sorted out, and there is no issue, and hence this vehicle was doing very well. But now with FAME 2 coming in, there are certain kind of riders where they would want to come out only with lithium ion vehicles. So only those qualify for subsidy. So the price has gone up. Second, also, if you see, banks are still not very proactive, considering that fact that in a e-rickshaw, typically batteries form close to 55 to 70% of the overall vehicle cost. And the income profile of the person also is, kind of very different. His education qualifications, etc., that do not give him that much, kind of comfort to the financer to fund these kind of vehicles. What we've also seen is, if you look at the two-wheeler and three-wheeler space in India, so especially in two-wheelers, apart from, kind of providing personal mobility, people have also kind of gone into the space of, B2B kind of services. So, the likes of Zoomcar, etc., have come out with a few e-two-wheelers which they provide on lease or on rent, kind of for riding in, a particular geography. There are companies like FAE Bikes, which is a Bangalore-based company, which is having a fleet of around 1,000 of vehicle at this point of time, and they have come out with various business models, for where they give this two-wheelers on lease or on rent for a particular time period based on the requirement that you have. Sun Mobility is, another company which, the earlier presenter also spoke about. So basically, they are into battery swapping in a big way. So, they are providing charging infra or battery solutions direct to customers. So they are into a different business model. Similarly, you have lithium ion, which kind of is kind of business where they are leasing batteries. So the financier is very kind of easily funding the body of the vehicle, but when it comes to battery, that can be leased from these kind of people. So different kind of business models are being followed to push business. Similarly, you look at three wheeler. So on the three-wheeler side, you have people like OK Play, which are on the B2C side. So where, they provide kind of mobility to people at large for both passengers and goods. There are, people like Smarty and Ola, which are more on the aggregation side. And, kind of, they work more like, aggregator platforms who use this kind of concept to, kind of promote e-mobility or clean mobility for that matter. Again, Sun Mobility and Lithium Ion in the similar fashion in which they do it for two-wheelers. So these are various business models that are there or prevalent in India at this point of time. If you look at it from an affordability perspective, this is only with respect to the initial cost. You actually see that the initial cost differential is very high. So if you look at an ICE two-wheeler, so it is somewhere close to 75 or thousand or 72 or thousand for ICE two-wheeler. Vis-a-vis that, if you look at a lithium-ion two-wheeler, it is somewhere close to a lakh or 1,05,000. So the initial cost is very very high. But with the things like BS6B etc. coming in the near future, where emission regulations are expected to be more stringent, we'll actually see the prices of BS6 vehicles going up to as close to 80,000, and we'll see the prices of your EVs, which include FAME subsidy, to be around 1 lakh. Now, at this point of time, the government has not announced any kind of program where they will be continuing FAME to post FY22. So once the subsidy is withdrawn in FY23, the cost again becomes very stark. But if you see over a period of time, this cost is kind of coming down. But this is with respect to acquisition cost. Now, what is very interesting is when you look at the next slide, what we've tried to look at is total cost of ownership. So, in total cost of ownership, what is it that we have taken? So, we've taken into consideration the initial cost, that is the cost of the vehicle. We've reduced frame subsidy out of it. We have kind of, also added RTO and insurance. This is added for ICE vehicles, but for electric vehicles, there is no road tax and registration at this point of time. Yes, there is insurance and there is some minor RTO fees. Then cost of finance, the average running cost that he may have. So, maintenance cost, charging cost, in case of ICE fuel cost, and for higher, holding period cost of replacing the battery and resale value. So, if you actually look at, how this stacks up, so you will be surprised to see that a two-wheeler EV for a period of 3 year and 5 years is today also kind of more favorable if I consider the total cost of ownership as compared to what it is yeah, as compared to a combustion engine. In case of 7 years, you will see that it is largely there is parity between ICE and EV. The reason being, in 7 year calculation we have considered battery replacement, and we have taken an extra cost with respect to battery replacement, and hence that prices going to be high. But on the other end, if you see, as such, e-two-wheelers are considered to be on par with basically combustion engine or better in terms of total cost of ownership as compared to combustion engine, which means they are more cheaper as compared to combustion engine. On the other hand, when you look at e-passenger vehicle auto, again, if you look at 3 year, 5 year, 7 year holding period, they are all better, as compared to the combustion engine. The only major difference here is if you look at, combustion engine auto, which is 2,55,000 for a CNG and 1,80,000 for a petrol. You look at the EV cost, it is 3,11,000. But if you remove the subsidy of 66,000 from this, you are looking at somewhere close to 2,50,000. So the initial cost is 70,000 more than a petrol and around 45,000 more than a diesel. But what is very important to understand is when you look at the range, so what we have indicated here is they claim a range of 170, but at this point of time they are providing a range of close to 130 kilometers. So taking all this into consideration, and look at the maintenance cost difference, 6,000 monthly as compared to 30,000, 25,000, and 15,000. And with the same level of running, we can see that they are anyways favorable even today. But the problem is twofold. A, charging infrastructure is one big issue that they are struggling with at this point of time. Also, the second part that they are having a problem is with respect to the finance being available. Now for combustion engine vehicles, the loan to value is as high as 85. So what it means, for every 100 rupees that the vehicle cost is, 85 rupees gets funded and 15 rupees is the down payment. In case of EVs, it is still 65 rupees, which means 35 rupees has to be the down payment. Now, anyways, the electric vehicle cost is much higher. So, for example, if you look at this, you will say that 2,50,000 is the net cost. And if I look at this, it is 2,05,000. So, out of 2,50,000, if I have to pay 35% of the vehicle, so I am paying close to 85,000 rupees here as down payment. On the other hand, if I have to pay 15% of this as down payment, so I'm just paying 30,000. So, there's a huge difference in the initial down payment that I pay. Also, my interest cost is close to 13% for a combustion engine vehicle and 18% for a e-auto or a e-rickshaw. Now, these are the things which are disincentivizing, users from migrating to this category. However, the government is slowly, gradually working in this direction, and going forward, we are expecting to see some kind of respite in this area. Similarly for e-rickshaw, now e-rickshaw you only have a e version. There is no basically combustion engine version. But if you actually see, as per our understanding, a lithium ion is much more better as compared to a lead acid. Can you put it on mute, please? Last two slides. So basically, when you look at the long-term demand potential for two-wheelers EVs, we at Crystal feel that by the end of 2030, we'll have around 75% of our scooter sales which will be EV, and 40% of overall two-wheeler sales will be electric vehicles. 40% because we expect low electrification in motorcycles, and hence the overall vehicle number is at 40%. If you look at from a three-wheeler perspective, so we are expecting around 65% penetration in EV three-wheelers and 32% penetration in goods vehicles. E-loaders and e-loaders is expected to be very low as a category, and e-rickshaws also, which we are expecting to reach a sales of close to a million by 2030, and we expect a population of close to 4 million e-rickshaws by 2030. So that's it from my side, guys. In case if there is any question that you guys would want to ask, I'll be happy to answer this.
Thank you very much, Mr. Thakkar, for a very comprehensive presentation. You gave the demand projections at the end. Just wanted to know that these demand projections, have they been basically informed by the survey which you conducted?
No, so we at CRISIL track around 85 odd industries on an ongoing basis. So we have developed our own demand models, and we have taken into consideration the total cost of ownership hello.
Yes, yes. We can hear
Yeah,
you.
we've taken into consideration the total cost of ownership, and basis all these parameters that we've considered, including the FAME subsidy by government, we have then forecasted how are we expecting the sales of e-two-wheelers and three-wheelers over the next couple of years.
All right. We have one question. It's regarding you mentioned that there's a lot of ladies are buying e-rickshaws under FAME 2. So the question is that is there any particular gender related focus in the FAME 2,
Right.
like in a policy level, or is it just being driven because of some other factors?
No,
Hello.
sorry, can you come breaking? Sorry, you said a lot of ladies have purchased e-rickshaws.
Yeah. So is there a particular gender related focus
Your
in
voice
the
is
FAME
breaking.
2?
I'm not able to hear you clearly.
Can you hear me now?
No, there is no gender related reason. Yeah, I can hear you now. There is no gender related reason as to why, e-rickshaws were being bought by ladies. It provided a parallel employment opportunity where the social status of women was considered to be far better than being a housemaid. and they were considered to be an equal earning partner as compared to a male who would go and drive hand carts or hand rickshaws or cycle rickshaws. So from that perspective, it has kind of provided immense opportunities to a lot of women in rural areas, largely in UP and Haryana, and we've seen that kind of increasing significantly.
Thank you. We have a question from Ms. Wajiha Tokir. She asks that, can you share the tools which you use for demand projection at the end?
So we look a lot of, we kind of utilize a lot of statistical tools, and apart from that we conduct a lot of surveys on an ongoing basis. So there are various ways and means in which we can kind of we forecast this kind of penetration for two-wheelers and three-wheelers. So no, I can basically speak to them in details or help them to understand how this is happening, but there is nothing specific that I can share with respect to these kind of things.
All right, so we could share your contact details with the participants, and then they can get in touch with you regarding further queries. We have one question from Mr. Saad Latif. He asks that, can you share more on the nature of charging stations that have been deployed across the country? He's curious to hear on the energy capacity of these charging stations and interested to hear on the overall footfall on those charging stations. And he's also asking, is the battery swapping common for two-wheelers and three-wheelers? Hello? Hi, Mr. Thakkar, can you hear me?
Yeah, I can hear you now.
Did you get the question, or should I repeat it again?
No, I did not get the question.
Okay, so this question is from Mr. Saad Latif of Karachi Electric Corporation. He's asking that, can you share some more light on the energy capacity of the charging stations that are deployed in India? And he wants to know the current footfall on those charging stations. And is battery swapping common for two and three wheelers in India?
Okay, fine. I'll answer that question. With respect to specific, capacity of these chargers, I can get back to you on a one-on-one basis. You can, kind of share. You can send an email to me, and I'll respond to it. Second, with respect to footfalls of, footfalls in these charging stations at this point of time is fairly low because of two reasons. The charging infrastructure is very minuscule in India at this point of time, and most of the vehicles, as you see, are all lead acid vehicles, that is e-rickshaws. So most of them are prone to home charging. Apart from a few areas in Bangalore and maybe a couple of kind of charging stations that have been set up by Mahindra and Tata Power, there are not many which are being set up in India at this point of time. So the scale at which they are currently operating is fairly low. Your second question with respect to battery swapping, if you ask me, that's a very interesting concept, and if the government pushes it to an extent, there can be some play for it going forward. However, there are two reasons for battery swapping not doing well at this point of time. Every manufacturer that is there in the country has its own way of kind of coming out with battery composition and hence the battery technology. So that is the USP of the vehicle, and the price of the vehicle differs significantly based on the battery type that he uses. Now, with respect to battery swapping, you will largely require common, specifications for batteries. Now, that is something which is not mandated at this point of time, and hence, battery swapping is probably not picking up in a big way. Yes, but going forward, if the government of India comes out with some rules and regulations which state that, with respect to public, transport, say like buses or three-wheelers, if the battery specs are defined well in advance and they ask manufacturers only to produce certain specification of batteries, then battery swapping can be successful in a big way. And, even the existing infrastructure with respect to petrol pumps, etc., can be utilized to dispense these batteries.
Thank you so much. Now we have final two questions. One question is regarding the sample size of the survey which you conducted. So
Right.
could you respond to that?
Yeah, so with respect to the sample size of the survey, so we have interviewed close to 400 odd participants in various cities in India for the e-two-wheeler survey. And for the e-three-wheeler survey, we have interacted with close to 200 odd drivers, of electric three-wheelers. And we've then spoken to a lot of startups, the ones that we mentioned, lithium ion, Smarty, Sun Mobility, etc., to get their views also.
Thank you. And the final question is, do you think the flow batteries or any other battery technology might overtake lithium ion in future?
So at this point of time, it is very, very difficult to say. Tesla is working on NCA, and kind of there are other manufacturers which are also working on solid state batteries, but there is not enough progress that have happened in that regards at this point of time. The most successful and the most reliable technology at this point of time continues to be lithium ion, though with various chemical compositions. But this is a technology which is proven, and maybe over the next couple of years, this is something that will stay. So that does not mean that any new technology will not come in. It will, even if it comes, it will take some time for it to establish itself and position itself. We've seen lithium ion come a long way in terms of proven technology, also in terms of cost. So for any other technology to be successful, they will have to kind of establish their credentials in that manner.
All right. With this, we conclude our question and answer session. I would like to thank you, Mr. Hemal Thakkar, for taking out your valuable time and giving us such a comprehensive presentation. It was basically for SAARC, from the perspective of SAARC region. This presentation was very important because it helped clear many questions, and there were many confusions regarding why there is so much growth of two and three wheelers within India. So it helped us understand, and how now we know the basic reasoning behind that. We understand the FAME 1 and FAME 2 policy frameworks. So overall, it was a very good presentation, and we thank you for taking out your valuable time.
No, thank you very much. Thank you, Umar. Thank you, the entire SARC Energy Center team. Thank you, Mr. Gul and Ms. Harina, for having me there. And it was a pleasure, kind of being a part of this conference. And please feel free to get in touch with me for any further clarifications that you may require. Thank you very much.
So thank you so much. So dear participants, with this, we now move on to our third presentation of this webinar. Our third presenter is Miss Arina Anisi, who is an Associate Program Officer at International Renewable Energy Agency, IRENA, in Germany since 2017. She supports the innovation work stream in IRENA, focusing on innovations for integration of renewable energy in power systems and electrification of end-use sectors. Prior to joining IRENA, she worked as an energy analyst at PSR Energy Consulting and Analytics, which is a Brazilian-based consulting firm. In this role, she carried out technical, economical, and regulatory studies of a wide range of power systems around the world. She holds an MSc degree in Electric Power Systems from Comillas University in Madrid and an MSc degree in Network Industries and Digital Economy from Paris Sud University. Ms. Arina will be sharing international experiences on smart charging for electric vehicles. So, welcome, Arina Anisi. You may please go ahead with your presentation.
Hello, everyone. Thank you very
Hi.
much, Umar, for the introduction, and thank you to SAARC for the invitation to IRENA to present our recent analysis on electric vehicle smart charging and the impact on the integration of variable renewable electricity. To start with the big picture, we look at the global energy transformation and the pathways for this. And our IRENA analyzes
Excuse me, Arina, your screen is not being shown fully. It's cut. It's being cut on the left-hand side. So I don't know if you could run it again.
You don't see the complete screen now.
Yeah, I can't see the complete screen. Only the right side of the screen is visible. The left side is not visible. The chart is not visible properly.
You see this complete now, or this one, or still not good?
No, it's
Okay, let me share it again, maybe. If I share it like this,
yeah, now it's visible.
now it's visible, it's complete.
Yeah.
Okay, thank you for,
Thank you.
I'm sorry for this.
No problem.
So I was saying that we look at the global energy transformation to put things a little bit in context. And the IRENA analysis suggests that the annual energy-related CO2 emissions under the current plans and the planned policies are expected to remain flat, but actually we have to reduce them even further by 70% to be aligned with the Paris Agreement scenario and keep the temperature rise well below 2%, 2 degrees Celsius. And this is the energy transformation pathways that we are working on. To achieve this, electrification, renewable energy, and energy efficiency are measures that can provide 90% of this needed reduction by 2050. And notably, renewable power and electrification of heat and transport alone can reduce these emissions by 75%. Now, looking a little bit more regional, we are developing a regional study on Central, Southern, and Western Asia, clustering these 16 countries extending from Kazakhstan in the north to Turkey in the west. So this region that we are analyzing, and I will give you some insights here, it's formed by West Asia, including Turkey, Central Asia, Kazakhstan, Kyrgyzstan, Tajikistan, Turkmenistan, and Uzbekistan, and South Asia, basically SAARC region. And we see that according to the current plans and policies in place in this region, CO2 emissions in the energy sector are expected to double. In 2017, there were 3.5 gigatons of CO2 emissions, and in 2050, they will reach 7.2. In terms of looking at the different sectors for the transport, we see that the population and urbanization growth are actually expected to increase the demand for transport. And as a result, the CO2 emissions in the transport sector will increase almost threefold from 0.5 gigatons CO2 in 2016. It will reach almost 1.4 gigatons in 2050. However, power sector is the one most responsible for the entire emission. SAARC is, we know that it's heavily based on coal generation. Central Asia is based on oil and gas. However, a good example is India. India is pushing back against coal capacity expansion and is focusing on scaling up competitive renewables to be in line with Paris Agreement goals. We see that in the past year, in 2019, India's CO2 emission growth slowed by 2%, which was actually the lowest annual increase in nearly 20 years. India has committed last year to an ambition target of installing 450 gigawatts of renewable energy by 2030. Also, looking at the industry, we see that there are increasing level of activity of energy intensive industries, especially iron, steel, metals, and chemicals and petrochemical in few countries, notably India and Pakistan. And this would require additional efforts and solutions to decarbonize this sector. This is the current plans. Now I will tell you a little bit more about the energy transformation pathway and what it needs to be done in order to be aligned with the Paris Agreement scenario. And this pathway for the entire region will actually need entail to decrease CO2 emission by 43% compared to the current levels. So in order to reach by 2050 energy-related CO2 emissions of 2 gigatons. The renewable share in total primary energy supply should increase from 8% in 2017 to 58% by 2050. And the renewable power generation in the generation mix should also increase from only 18% to more than 80%. That's from 18 to more than 80% by 2050. Now looking a little bit only on the transport sectors and on the electrification of transport sector. Electrification, it's actually an emergent solution for many end-use sectors, taking advantage of low-cost renewable electricity that we have now, competitive solar panels and wind in general. So in our IRENA analysis, we expect that the share of electricity in the transport sector would increase from just 1% in 2016 to more than 40%, 43% in 2050 in the energy transformation scenario. Also, we have here numbers from the increase in electric passenger cars, electric buses, electric 2- and 3-wheelers. Today we see globally 200 million units, and this would reach would increase 10 times more to 2,000 million units. And also the batteries, the battery storage that would be available to the grid from electric vehicles in general would also increase from 0.5 gigawatt hour today to almost to more than 14 terawatt hour in battery storage from electric vehicles, and this is higher actually than the capacity provided by stationary batteries, which would be almost 9 terawatt hour. Now looking at the region, we see that it's in line with the global numbers, that the renewable based electrification in transport currently it's only 1%, and should reach almost 52% by 2050. So incremental tremendous increase is needed. And on the total capacity battery provided by electric vehicles, the region will account for 5% of electric vehicles, for 5% of the total capacity from electric vehicles, accounting for 670 gigawatts hour, and 1.3% comparing to 1.3% of stationary batteries at only 115 gigawatt hour. All this regional analysis is currently included in the Global Renewable Outlook Energy Transformation 2050 that will be launched in the next couple of weeks, and it will be available on our website. So please keep an eye on this. This could be very interesting for further reading and very timely. Also, having said all these numbers, I want to discuss a little bit about the benefits and actually the drivers for this energy transformation in the region, in Central, Southern, and Western Asia. And we see that one of the main driver and benefits is the reduced local air pollution and emissions and improved health. South Asia especially is currently the region with most toxic air in the world. And 18 of the world's 20 most polluting cities are located in India, Pakistan, and Bangladesh. In 2019, actually, New Delhi, the capital of India, experienced record high levels of air pollution that reached 50 times the safe level deemed by the World Health Organization. So these pollution levels led to complete shutdown of city activities and caused serious health issues. We see this is a very serious problem, and energy transformation provides a big benefit in this sense, and renewable energy. Then the region will benefit from energy independence and universal access to clean energy resources, diversifying the energy supply and distributed and competitive renewable sources would basically allow economies that currently are dependent on fossil fuel revenue to increase their resilience to external shocks, and such as fossil fuel price volatility. Also, isolated communities could benefit from distributed renewable energy sources and have a clean energy access. Last but not least, economic and sustainable development. It's also one of the main benefits, as renewable improved job prospects and for the world's largest working class group. These energy transformation benefits actually go hand in hand with electrification of transport benefits. Introducing electric vehicles in cities reduced considerably the air pollution and noise in these polluted cities and crowded. Then it can also reduce dependency on imported oil for transport sector, as none of the SAARC countries produce oil, so the transport sector is dependent on oil imports. And we see that in this region mostly 2 and 3 wheel batteries are better suited with the purchase power of the people. It's easier in general for people in this region to buy motorcycle, given the traffic, the crowded areas, and the purchase power of them. India currently has 3 million cars and 12 to 15 million motorcycles, so 4 to 5 times more motorcycle. And electrifying the transport will follow the same patterns. Electrifying will be basically electric 2 and 3 wheelers. Now going a little bit more in depth into our study that was released last year, smart charging for electric vehicles. We looked here at how to charge the electric vehicles smart in order not to pose overload to the grid, to the distribution grid especially, and in the same time to harness synergies with renewable electricity so that the car can be charged with mostly renewable and decarbonize the sector. So smart charging means actually adapting the charging cycle of electric vehicles to both the condition of the power system and the needs of the vehicle users. So this would facilitate the integration of electric vehicles while meeting mobility needs. And there are various types of smart charging, from very simple ones, time of use tariffs that basically sends a price signal to the consumer to defer their charging from peak and off from peak periods to off-peak periods, and to more advanced smart charging that could include also automatic control to digitalization and unidirectional control. The smart charging means basically adjusting the level of the charging, while bidirectional controlled charging means that the car would be able to provide electricity back to the grid and other services. So we have here V2G, it's called vehicle to grid, vehicle to home, when the car is connected behind the meter and it can provide electricity actually to the home behind the meter, or vehicle to building. Depending on the complexity of the smart charging adopted, the car could provide increased or decreased flexibility to the grid. For more advanced and more automatic smart charging, the flexibility that can provide to the grid increase, of the flexibility that the car can provide to the grid would increase. So we know that electric vehicle innovation, it's actually an innovation for the transport sector. Its main goal is to improve air quality, to decrease pollution, and to decarbonize the transport sector. However, if with large deployment and if the cars are connected to the grid 90% of the time, as of today, power sector can take advantage of these connected batteries and integrate more renewables and balance better the grid. And here this is the main motivation actually for vehicle to grid smart charging, when the cars are connected and the battery is connected 90% of the time. And we looked more in depth into the benefits of vehicle to grid smart charging. And batteries in electric vehicles can be used for as stationary battery, basically, if the mobility needs allows it. So it can be used for peak shaving, or it can be used as a backup for the grid. And it has great synergy, especially with the PV production, solar and electricity production, to charge the battery during the day when the sun is shining, and to discharging in peak at the peak evening to cover the peak demand, or in case of grid failure. There are different services also besides providing electricity back to the grid. Through vehicle to grid smart charging, the car can also provide different services to the TSO and the DSO, like voltage control, frequency control, to alleviate congestions in the grid. And this would be a second revenue stream for the electric vehicles. So for this to happen, actually market structures and regulation are very important. Allow stacking revenue should be allowed, and also new business models should emerge, such as aggregators, to bundle together different more electric vehicles to have a bigger pool of capacity to be able to provide services to the grid. We see that normally capacity of at least 1 to 2 megawatt have to be traded on the market. So that would mean an aggregator of around 500 electric vehicles are needed to be able to trade the electricity and the services in the wholesale market. So this is something that we look at as an important enabler for harnessing synergies between electric vehicles and the renewables in a future where electrification of transport would be already there with a lot of electric vehicles deployed. But we have to think already from now on what kind of regulation we need, what kind of chargers we need. To exemplify a little bit the impact of smart charging on grid infrastructure, I brought a real case example of the DSO in Hamburg. They made an assessment at 9% electric vehicle share would cause 15% would cause bottlenecks in 15% of the feeders in the city's distribution network. So they assessed the two solutions. One is grid reinforcement that would basically cost 20 million euros, and another one it's smart digital solution involving smart charging that would cost only 2 million euros. And this solution involves they basically decrease simultaneously, meaning that the number of electric vehicles that are charged at the same time would decrease, and the DSO would be able to reduce the loading current for charging electric vehicles and avoid overloading the local grid. So for this solution, smart charging, basically we see that it costs 90% of the other solution, the grid reinforcement solution, and the DSO of Hamburg partnered with Siemens for smart charging and would install 30 control units and monitor all the private charging infrastructure loads. As we've seen also in the previous presentation, to electrify transport, it's not only needed the vehicle, the electric vehicle, we also need charging infrastructure. And city planners and we have to make decision on how is best to charge the electric vehicles in the city. There are different options from slow charging to fast charging to ultra fast charging. Slow charging are usually better suited for smart charging. However, fast and ultra fast charging are a priority for mobility sector. Nobody wants to keep the car too long charging if they will need the car immediately. Fast charging, it's increasing stress on local grids. However, there are innovative solutions like battery swapping, charging station with buffer storage that could help this situation in case fast charging points need to be deployed in some, like in highways or some other circumstances. Also, important question is where to place these charging points. There are home charging points, charging hubs, public charging, commercial, office charging. So it needs also a little bit of planning around where to place this. And here we looked at at the city characteristic, and we see that different city transport patterns will impact charging needs. To a large extent, these patterns are determined by the interplay of population density and the level of economic development. We have seen, we did this exercise to map some cities according to the GDP per capita and the population density. And we see that as higher the GDP per capita and lower the population, people will normally go for electric vehicle, private cars, and home charging will be probably the most suited one. Once we increase a little bit the population density, people will opt more for also private cars, but also shared mobility. And given that they are living in more densely populated probably home charging will not be available for everyone. So charging hubs and the fast charging station would be a solution. However, if we decrease the GDP in cities with decreased GDP per capita and higher population density, such as Mumbai, Manila, we see the public charger for 2-3-wheelers will prevail, and also hubs for charging buses. Public transportation it's essential. Two-wheelers will dominate India's electric vehicle market. We looked at many startups and also established players are announcing the launch of different two-wheelers. So we see that this would be one important player in electrifying the transport in India, two-wheelers. As I said, charging stations are very important to electrify the transport, and India and normally government support is needed to help deploy the charging infrastructure in cities and country. India has last year, I think, approved a program for establishing 2,600 charging stations for electric vehicles throughout the country in 62 cities. However, private sector is not always waiting for governments to act, and innovative business models emerge to try to bridge the gap. Here, I just bring an example of one innovative, one business models that we came into, called by a startup in India, Kiara Scherzer. They developed very low-cost charging points of around 10,000 rupees, and they're selling it to different shops. So owners will be able, from the shops and or different whoever buys it, will be able to set their own price through the application, and will receive all the avenues from charging the cars. It takes up to 2 hours to charging time for the scooters. Solar connection is planned in the future, not yet. Now it's only a pilot project, and 470 charging stations has been already ordered in this pilot stage. It's just an example. Also, we see IoT, Internet of Things, very important here. This allows basically the host to set their pricing and their availability, and to make the charging station discoverable and operate through the application. So interconnectivity is very important. Another innovative business models that I wanted to bring up here, and I've heard also in the previous panelist speakers, it's battery swapping. Battery swapping already exists, and it's mostly developed, we see, for buses in China and South Korea, and two-wheelers. Here we brought an example from a startup, Gogoro Smart Scooter, that it's in Taiwan, and they have swapping stations that run on solar power directly, as we can see in the figure. I will pass a little bit faster on this, and I will come to an end with this presentation on electric vehicle smart charging with some guidelines for policymakers. We made a 13 steps plan for policymakers to have in mind when deploying electric vehicles in a country or a city. First, and very important, one of the very important ones is to support charging infrastructure, because electric vehicles deployment is dependent on charging the infrastructure, and promote renewable energy hand in hand with electric vehicles in order to have a truly decarbonization of the transport sector. Then they would need to think to design smart charging strategies to fit the power mix in their own context. And finally, an integrating planning of power and transport sector that go hand in hand will be needed, as this will be very connected sector coupling. I would like to suggest you some further reading for some reports that were launched last year. Innovative Outlook, Smart Charging for Electric Vehicles. It's an extensive studies on different opportunities to harness synergies between electric vehicles and the renewables through smart charging, as I give you some insights. Innovation landscape for a renewable power future. Here we look at the broader innovation that offer solutions to integrate variable renewables. We looked at innovation not only in technology, but also in business models, in market design, and in system operation. Electric vehicles is one of the innovation that we mapped here in this study, and we also wrote a separate brief, shorter brief to the point on electric vehicle smart charging. All these are available for free to download on our website. And don't forget, in a couple of weeks, our new study on global renewable outlook will also be launched, and there will be a more, a regional study on the energy transition, as I introduced you in the beginning. One of my last one of the last announcements, we are also doing at IRENA a series of webinars, IRENA Insights. It takes place every 2 weeks. Today we have a new edition in shortly after this webinar. If you're interested to connect, feel free. It will be actually about the innovation landscape report for 100% renewable power. But however, you can feel free to check the website, and if you are interested in the topic, to connect every time, you are available. And then we are organizing in September in Bonn, where we are located in Germany, a conference called IRENA Innovation Week. Also, keep an eye on the website, and feel free to let us know if you're interested. It's a participation for invitation only, but one of the main topics discussed will be electrification of end-use sectors, and of course, electrification of transport is an important topic. Thank you very much for your attention, and I'm looking forward to answer any questions if you have any.
Thank you so much, Arina, for this presentation. I'm sure that all our participants, they would be interested in your today's webinar as well. We will share the link of this webinar separately, and I'm sure you'll get good participation from our side as well.
Thank you.
We'll move on to our question answer session. So the first question is regarding the Hamburg example which you quoted. So the question is that the solution B, for solution B, the DSO could control the load of charging points. So if some consumers require fast charging during the peak time, so how would the DSO respond to such a demand?
Yes, that is a very valid question. And how so smart this is done through contractual agreements between the DSO and the consumer. So the consumer is signing that the DSO is able to control its load in some specific situation. If this would help the grid. It's basically for the home chargers that the consumers have in their home that are usually not fast chargers. They're slower chargings, and the DSO would be able to manage the load and the current to charge the electric vehicle at a significant level to make a difference for the grid, for the distribution grid, but not to postpone too much the charging of the car. However, these are not fast charging. Indeed, when there is a fast charging, the priority of the charging is to charge the car as fast as possible, not taking into account so much what is happening in the power grid. And if these some solutions to overcome the congestions and the problems that might appear in the power grid is to have buffer batteries, to install stationary batteries at the charging point. So the charging point will use the batteries instead of the grid, and the batteries will be charged wherever possible.
Thank you so much. There's one more question. Is there any business model currently under consideration to realize V2G smart charging, vehicle to grid charging business model?
Yes, vehicle to grid is technically possible, but as we have discussed largely with the industry and also mostly in Europe and in United States, we see that so far there is no monetary incentives in the sense of real business model to take up on this, because the Nuve, it's a US company that it's piloting in a lot of countries and trying to see how vehicle to grid will work and what will be the rate. Yeah, Nove, it's a startup company that it's piloting a lot of projects all over the world with vehicle to grid, and the business model for this is basically stacking revenue. The car receives revenue for each of the services they are able to provide, either to the DSO for the congestion, the grid, voltage control, or directly to the entire system, to the TSO, frequency control. However, these services are yet not probably very well monetized at the moment, so the revenue that the car might receive at current pricing levels is very little, but it's something to be explored mostly in the future when many electric vehicles will be deployed and the pool of batteries connected to the grid would be large in order to really make a difference for the grid and to support the grid. At the moment, it's just a pilot project. It works technically, but yeah, as a business model, it's not very strong.
All right. So we have a final question. This question is regarding, you mentioned that out of 20 most polluted cities, most of them are in South Asia. So the question is that do you have any, does IRENA have any projections that where will those South Asian countries stand, let's say in a decade or by 2050, or do you have any particular study done for South Asia regarding this matter?
Yeah, as I said, we are releasing in a couple of weeks this new study, Global Renewable Outlook. It has a regional focus also on South Asia, Central Asia, and Western Asia. These regions are banded together. One of the metrics that we analyze there is the pollution in the cities. So I think it would be very interesting. As soon as it's out, I will definitely write you an email and let you know. But for all the other participants, please check our website. And yeah, I don't have an answer for you yet right now because the study is not finalized, and my colleagues are actually working on it, not me personally. But I can tell you that one of the metrics analyzed it's the air pollution there in the region.
All right. We just got two more questions. I got them just now. So one question is from Mr. Kashif Shah. The question is that regarding smart charging, what are the combination of protocols being used in practice? For example, he mentioned some protocols, OCPP, Open ADR, IEEE 2030.5, etc. So the question further on states that what's the criteria for selecting such combination of protocols, and is the DSO responsible for data hub management for coordination activities? From private perspective, how much years it would? Yeah, sorry. So I will repeat the question again. So number one, he is asking about the combination of protocols being used in practice. So what are some combination of protocols? And secondly, is the DSO responsible for data hub management for the overall coordination activities?
So for the first question with protocols, I don't know the names of the protocols and all these technical details. I can check, and I can maybe, if he can write to me an email on this with these questions on my email address on the screen. I can try to provide him some guidance of the information we have in this regard. But I don't know it by heart. This combination of protocols, and on the DSOs. What was the question? That if the DSO
Yeah, the question was, is DSO responsible for data hub management for the overall coordination activities? Like, will the DSO, apart from handling the load, will also be responsible for managing the data communications and data going on between different points?
Depends from countries to countries. I think the DSO's role is evolving more and more with all this decentralization and with electric vehicles and rooftop solar panels and distributed energy resources of any kind connected to their grid. So it's more a general question in the context of decentralization and the general role of DSO that evolves, not particularly on electric vehicles. I see it because, yeah, there are also heat pumps that are emerging and many things happening at the distribution level. Now, uh, it depends on the regulation. Basically, I think in some countries they are exploring this option of DSO being responsible and managing, because DSO is the first one that have all this information collected through through smart meters and connected to the grid. However, there are also a possibility to transfer all this to a third party and centralize it, send all this information and make a third party responsible to handling the data center of what's happening. Also, it's a problem of privacies that occurs here, but I think it depends on the regulation. We have some studies also on the future, these emerging roles of distributed system operators in the context of decentralization. It's part of innovation landscape report and one brief. So feel free to look a little bit on our website on the innovation section. But this is heavily depends on the regulation of the DSO and how this changes.
All right. So there's one more question, but we would take this question with the final presenter because of the lack of time. And I would ensure that this question is answered. This question is by Mr. JT. So please stay with us. We will answer this question at the end of the final presentation. So with this, we conclude our question answer session for this current third presentation by Arena NEC from Irina. I would like to thank you for your time, and it was really a good presentation. You took out time despite your current engagement with another webinar as well. So profound thanks from our side. Okay, so now we move on to our final presentation of this this session. This presentation is by Mr. Gul Hassan Bhutto. Mr. Gul Hassan Bhutto is the head of engineering and operations at Omni Power Pakistan. He's an engineering professional with academic training in electrical power engineering and business administration from IOBM. He has over 16 years of professional experience in the fields of power generation, policy, planning, maintenance, operations, performance, and contracts management. He has also worked with Caterpillar and General Electric in Pakistan in various capacities, including engineering, projects, services management, and leadership role. Besides his engineering activities, he is a keynote speaker, panelist, analyst, and technical writer as well, and publishes regularly on critical issues in energy and power sectors. He also has served as a visiting faculty at various academic institutions, including NED, UET, and others. He will be giving presentation on EV global outlook and policy framework for EVs in Pakistan. So, Mr. Gul Hassan, can you may please proceed with your presentation.
So thank you very much, Mr. Umar, and thank you very much, SAARC Energy Center, for inviting me to present on the electrical vehicles, and thank you for your introductions. You have told about me a lot, and I'm sure that people might be expecting a lot from me, but I need to clarify that, hey guys, I'm not the EVs expert, but just as a practitioner of energy and a student on on the subject. I think we have very depth of information from the last presentations, and then of course it was a very good opportunity for me to learn from all that from different perspective on this subject. But moving forward, I would try my level best. What has already been discussed, I should skip it, and then we could have a different perspective of the things in moving ahead. Just proceeding ahead, I need to check too. Is my voice clear? Is my presentation in full view visible to all? Umar?
Yes, sir. You're audible.
And presentation is also clear, no?
Yes, presentation is clear and visible.
That's wonderful. Okay, to proceed. So from all these discuss the three presentations that are already done, there's a question in my mind comes that what we are talking about today. We are talking about today one of the greatest disruption that is going to happen ahead. That disruption would have taken in this globe 1 century ahead, but by any means, whether it was blocked or whether it was not supposed to happen, but this is a kind of a disruption that, and it's a kind of a reality that is going to happen from the technology perspective, and also from the most from the arena presentation, like we heard, that the climate is the main thrust to that in order to have that disruption happen too. From the climate perspective, one thing that I need to need to discuss here is that one. Let's say, what is that all about climate? Why we are so fearing about that one, and then we are disrupting our business model, whether it's an EV or whether it's a transition from the thermal power plants to renewable power plants and all together. Since we all know that this atmosphere that we live about, the 7 billion people we are living about, that we are having about, we need the oxygen, the source of that oxygen, 70% is around from the trees that we are having on that, and around the 30%, 30% of that oxygen that we are having from the seas. So what is actually the problem that we are facing this today? That atmosphere that atmosphere is a constant that has a constant oxygen that these 7 billion people are taking for breathing
Excuse
and
me,
then
Mr.
surviving
Bhutta.
life.
Only
Yeah.
your first, I don't know if you have changed the slide, but we are seeing the first slide since a lot of, since like 4 or 5 minutes. So
Oh,
are you
oh,
changing the slides or not?
yeah, yeah. I have to. I was basically on a just a little background with the voice
All right.
note. I mean, now I would be moving ahead with the slides.
Okay, perfect.
So the atmosphere is these days the atmosphere shall have the 36 billion tons of a CO2 into that one. If the current stated policies in terms of the thermal power, transport, and energy goes on, then this atmosphere is not going to sustain more, and then we have the climate issues. So the point is, these CO2 emissions need to be brought back to the from 35 or 36 gigatons to a 10 or 12, something like that one, as has been envisaged into the different studies, and then the last president spoke about that one to ensure the sustainability. How that can be achieved? That can be achieved through the different adoption of I mean, business transition and disruptions, like transport is one of them, being the contribution after the energy industry. Then the third is the transport that contributes to that environment. So all that, just telling that the EVs are the reality, and then that is going to happen, and henceforth the things that are happening now to give the space to the EVs. You might have been learning about the news that the 5 weeks later, the Daimler has abandoned the internal combustion engines development to focus on the EVs. That's something the optimism that we need to look for. From the historical perspective, if we see for the EVs, among the earliest automobiles, and the contrary to the common beliefs, electrical vehicles actually predate the internal combustion engines. First mass-produced EVs appeared in USA in 90s, one point of the history, and outsold in the gasoline and power. Later on, vehicle speed and distance record in the 90s. EVs, like we said, the first EV editions had given us in the 1914, and then had it been carried, then there would have been the flood of the electrical vehicles and then the lesser impact on the environments. But the one must think about that when what happened 100 years before, if the EV was in our thought, then what happened with that one, and then why it vanished and it was not given the space. Basically, the new infrastructure and then the major discoveries, discoveries in the Texas, Oklahoma, Venezuela, California, in the early 90s, the oil discoveries, and then followed and so on. You see the oil market disrupted into the 60s and 50s into the Gulf also, and then the new then the Henry Ford started with the business and all their internal combustion technologies. So the other stronger thoughts take over the market, and then these were the EVs were pushed back. So in the we can say a mystery which has been the subject of a movie also, who killed the electric cars. So point to say into that slide that all that EV is not the new thing, but it's a reality. Though it's a good news to know that everyone these days is talking about the EVs, and this will is going to happen, and almost all of the manufacturers, whether it's a Toyota, GM, or Honda altogether, making the joint ventures, are directly producing these, have discontinued, got very popular versions of the EVs, and are suddenly discontinuing from the IC engines and then moving towards the business of the EVs also. The modern EVs, question comes in our mind: what is the thirst for these all EVs that they are coming? Because in the future, on the walls, it is written that the future, keeping in view the climate change, the oil and coal has to peak when, by 2030 or 35, or but not beyond, later than 2040, something like that. Like you might be seeing from the oil perspective, in the last year 2019, Venezuela, that used to produce oil of 1.6 million barrel per day, its production came down to 0.3. And then Iran, that used to produce 2.8 million barrels of oil in a year, in the last year, that came down to 0.3 or something. So look how that oil is going, demand is reducing globally, and then where that demand was off taken, that of course there was a major role into that one, the shale oil from the USA and all together, and then the fraction of that was also partly goes to the EVs evolution. Similarly, climate change is a big thing that's I would say that the climate in the past, any business that used to come about, we just talk about the two indicators: the viability of the business, and then if I go to the bank for the financing, they ask me about the business viability, and they ask about the financial risk leverage. But the future, the climate has changed, that why nobody is going to ask us about the viability. Everybody would be asking us about the business that we are going to initiate is the sustainability. And then of course the financial institution would less ask about the financial risk coverage, but they would be asking about the climate risk. So when the business models ahead, all the lending agencies are tuned up in a way that they need to ask about the sustainability and climate risk coverage. Hence it is important that's, and then other disruptions that is coming, as we have the challenges into all that in order to meet the climate targets. Of course, you have to shift from the conventional energy sources to other sources like renewables, and altogether there comes the variability of the renewables. Henceforth, but we need to have an storage, and in the storage side we have very leaps of the development, especially in terms of the batteries. So oil is going to die, the climate is going to be cured, and then henceforth the EVs are the main thing that they need to live. And then this is what we earlier said, that this is the reality. Henceforth, top automobile players are launching or have already launched the electric versions of their vehicles. And then China will have the 100 EV makers in. There are more than 100 EV makers in the China. And then of course there is Tesla. That is the one that has brought the disruptions. Of course, anything like I remember here the one disruption we need to I mean keep in mind. Such disruptions I have when I study and I look into the back, the disruptions always comes outside. What do you mean by this one? I mean to say, like let's say I remember one thing of the Fuji and then Kodak, because they were the one that has got the created the that digital camera. But when it came to the launching, they thought that we are not going to launch that digital camera because our film business will die. Henceforth, the EVs were already there. Then the Tesla is basically a disruption from the outside that has led these thousands of companies of internal combustion engine vehicle manufacturer to think about the EVs. This is bit I feel that the Tesla would be doing the wonders ahead in terms of the challenges that we have in terms of infrastructure, the range, the cost, and something like that one. So the question as of today also comes in mind that the why EVs, why not? And then since what we are going to suffer, we have such a series of petrol. What would be happening with all these infrastructure already at the place in terms of the petrol pumps, the refineries, the oil drilling companies, and all together, and that is the push and momentum why we need it. Of course, the cost is always the driver for that one. And earlier we talked about the economy linked with the energy. So economies of the globe were linked with the energy growth, but today I would say the economies are linked with the energy and ecology too. So ecology is the main driver that we need to grow very with the sustainable growth without damaging the ecology. Henceforth, from the EV's perspective, per kilometer basis, EVs are up to the 10 times cheaper than the conventional vehicles. Typically, EV, and then it's all about, we normally talk about the capex. I would say on any technology, whether it's a power plant, whether it's infrastructure project, or whatsoever it is, we have the two cost splits. One is the OPEX and the other is your CAPEX. So even today, the EVs, if they have the OPEX is bit expensive, but on the life cycle level, you need to see also the OPEX side, which can be a cheaper. EVs having the very less parts, around 18 moving parts, whereas the IC engine shall have the more than 2,000 moving parts. How henceforth, the more management, more cost, more parts, more trouble, lesser reliability, and less effectiveness, and more maintenance intensive. And then next to zero maintenance cost, hence the EVs have the less maintenance cost, and the latest EV model promise anywhere between about 5 lakh to 1 million life. I mean, the 4 times the life. Once you have the internal combustion engine conventional cars, that might be last about 4 to 5 years, and that's the car that you can take it up to around 10-15 years. So life is there with the less maintenance, and then more saving, and last but the most important, it's ecology friendly and helps us to decarbonization. And of course, the cutting down of air and noise pollutions are the other targets that we are looking for in order to see the environment, to see the sustainability. So there are, so let's say if you see it, चलो मैं कॉल करता हूँ दूसरी लाइन पे. So on the global long-term passenger vehicle sites, if we see how optimistic we are on the globe, and then how the EV would be penetrating into the globe, then and then we see the Bloomberg New Energy outlook says 2019 outlook of Bloomberg says that the even though today population is the lesser, but they see by 2040 around 70 to 80 millions of the battery electrical vehicles, hybrids, electrical vehicles, and we can see how the share of the internal combustion engines is getting to be reduced, and how the battery battery operated electric vehicles are taking up. So the future is for the vehicles. So there they believe this graph shows that by the 2035 or 26, these annual share of the sales in terms of percentile, they would be crossing about 25, 20, 36. The current, I mean, the global EV and conventional cars share of a long-term passenger vehicle would be going to cross it in the 2036. On the next slide, again, in terms of global long-term passenger vehicle fleet derivation, how that is the reduction by 2040. You will have the basically more of the battery electrified, and for example, we can say if today by 2021 we have the 1.2 billions of the global internal combustion cars, then by the 2040, if the total population is about 1.6, that is coming from this growth is coming from the electrical vehicles, and then replacement also of the existing fleet. And then in this slide that is shown that the EV share of the global vehicle fleet by this segment, that's the red is to the buses, and then blue is to the light commercial, and then violet is to light commercial, and then blue is medium commercial, and then yellow is towards your heavy commercial, accordingly in terms of the share of a fleet in percentile. And then commercial vehicle, not largely that expansion would be coming into the China, Europe, and then US. Of course, the Asia is the part, and then also the India too. And then in the that's an again representation of that slide in terms of a percentile, that we would be saying that in the total growth, there would be what would be the India share, and then US, and then China altogether. So we would be seeing the higher density of electrical vehicles into the China. So from all that global perspective, from the ecology perspective, their need and drive, and then telling that the EV's expansion ahead is a reality. What Pakistan is basically doing in that segment, I would brief upon Pakistan, brief upon the national electricity, national electrical vehicle policy. Is being developed by the Pakistan, and it has a very effective incentives in order to ensure the upcoming investment into the EVs area. Objective, there are the three objectives set for that one, though Pakistan being into the having the low carbon footprint, even then we are looking forward in our year 43% of the airborne emission in Punjab are from the transport, almost twice as much as in the developed countries. Reduce and from that perspective, from the climate perspective, let me tell one thing over here, that the mostly global per capita of the emissions is 5,000 5,000 tons per person, and then it's the highest about 20 to 22,000 for the per capita of the US, and then China is around 10 to 12 per capita. In total, like we call on the climate side, we talk about the 36 billion tons of CO2. The 15% contributor into that total emissions is the US, and then 30% is the China, and around 12% is your Europe, and then we have the India, and then the rest of the world. Hence, from that perspective, we have a very low footprint. But moving forward, of course, after the ahead, since the UNFCCC always talks about the nationally determined contributors, hence we have ahead in the COP25, there are also the needs for every country. They need to give their NDCs, and then from that perspective, EV policy is thrust in a way that we will have a very good space, and then incentive in a way that the EVs can be implemented very easily. And then, of course, we are 25% of our import bill is now oil dependent, which comes to be 10 to 12 8 to 10 billions billions, of course, replacing that one. In terms of power, today Pakistan grid is installed base is 36 gigawatt power, that we can 36,000 megawatt is installed in grid. But unfortunately, the winter demand is hardly 8 to 10,000 megawatt, and then summer demand are, I would say, the ability to evacuate that power is hardly to 26 to 28,000 megawatt. Thereby, you will have the 4,000 to 6,000 surplus into the grid, thereby meaning you have the power available, but we are not able to evacuate, or we do not have the ability we do not have the load to be catered. Henceforth, this is a good opportunity that if the EVs are coming into the grid, then we shall have the additional demand from the grid, and of course, the more utilization of power capacity, henceforth adding into the better economies and better improvement of the power sector, and then subsequently the economy. So EVs penetration targets that has been set into the EV policy in Pakistan. Commercial vehicle 100,000 by 2025, and 30 which and the two-wheelers are targeted about the half of the million by 2025, and buses are 1,000, and then is also 1,000. So this is, I think, the target that the government has set into the policy. And beside to achieve that one, the government has given a very impressive fiscal and financial incentive. And in general, those are all existing incentive under the other development policy 2016 shall remain intact, because and for the EVs, only 1% of the GST for the next 7 years would have been imposed, so that if you are importing an EV, you just have to give a 1%. Also, there is an exemption from the registration fee, and then annual token and taxes, and reduce custom duty on the import. Permission to import EVs also, permission to import used EVs also allowed, and then subsidized financing rate for the EVs leasing. Like in the power sector, we have the financing facilities. Like, let's say if somebody is going to install a power, then the state bank would be giving him a financing under 6% for over a tenure of the 10 years with the 2 years grace. Accordingly, here the government is pursuing with the state bank to have a such kind of the facility in for the EVs too. So, what is special measures are other? The government is seeing at that side. The government shall purchase has envisaged to purchase about 100,000 all electric buses and trucks, and then will ask commercial operators to operate them for the certain period. Almost, it is also envisaged that the metro buses and BRT routes in the Lahore, Islamabad, Rawalpindi, Multan, Peshawar will be prioritized for electrification of the buses. The policy also covers the charging infrastructure and allied industries like lithium-ion batteries, and similar fiscal incentive will be provided to these industries. I mean, anyone, let's say that was to the EVs. If anyone is putting in an EV industry, hence for their incentive for that one. The charging stations will be rolled out along main highways, motorways, and in the city center, so to minimize the range anxiety associated with the EVs. So that's from the policy side. And then what we are basically seeing the impacts on the grid side, how that would be helpful. Like in Pakistan, as we said already, we have a surplus capacity into the system, and of course how we can implement. So that's a good opportunity for the Pakistan, because the electricity is available for you, and then moving forward, that can help to develop an infrastructure. EVs, while primarily mobility solution, increasing being viewed as a grid flexibility solution, like we would be discussing on that flexibility side when we more in the previous presentations, as smart charging solutions are discussed. And this is I mean, I would say that that would be mobility, increased mobility, and EV would be giving a space to the energy utility companies to have a new load. Optimal EV integration will be function of a charging pattern habits of an EV owner, energy mix on the grid, of course, and then energy mix, energy charges, more of the medium long-term measures. Charging pattern relatively easier to control. On that perspective, when you have the EVs in currently let's say, so the smart charging perspective, the interest, you have the excess electricity, and then you would be have the better opportunity and then better tariffs from the utilities to develop that side. Smart and then grid flexibility, and then on the smart charging side, that in the last presentation would have been covered. Also, there would be there you could have the option whether the unidirectional you grid is there to charge your car, or by the from the vehicle to the business, whether the vehicle is charging to your any business unit, or sometimes the vehicles are giving the power to the grid. So smart charging, how does it helps, like during the shells, the peak demand and full or grid load balancing by adjusting the charging levels, and also this EVs may help to reduce the grid congestions and altogether, and helps customers better utilize their existing infrastructures, infrastructure. Increase new renewable power self-consumption, both for the customers and then the grid. Of course, in the because access to electricity in the Pakistan is normally, let's say, to the 70% people, and 30% people don't have the access. Of course, the renewable, especially the solar, is the lifeline. Those areas, even where there is a lack of electricity and access, and then microgrids concept, and then electrification in that area is being done. If that can be a country like us, where the job opportunities, and then the economic slowdown is there, even into the countryside, a farmer or something like that, we could have the solar panel, and then like we have the capital intensive businessman could only hardly install petrol pump and something like that for the conventional cars. But in that case, I would say that it would be a good opportunity that even for the areas where there is no access to the electricity, a renewable solar park can be installed, and thereby it's feeding to the community, and then it can give space to generate a business, thereby you can have electric cars charging or something like that. Other EV, but in that case, EVs has certain challenges too. Slow charging, mostly for the homes and office charging, and tariff in Pakistan, bit of the challenge. We have the higher tariff from the affordability perspective, because today tariff is 17 to 18%, which is day by day is increasing, because as we said that we are into the surplus, hence for the surplus is carrying the capacity. But the renewables are again hope, and then the next hope is coming in that when the by October 2021, all these discos exclusivity would be taken exclusivity into the sale business will end, and then the electricity market is being to be implemented. Henceforth, I see a big opportunity, like in K Electric or in the ISCO region. The sales function of that ISCO would be split into the private sector. I mean, there would be a private market participant, and then he can have a connection separate, and then he can be entered into the sales. Hence, into the infrastructure side, I see when this private participants are coming, and then they can have a very good access to that when an infrastructure issue can be solved. And then when electricity comes into that competition in October 2021, thereby I see a big opportunity on the lower tariff, and then on the denser intensity of an infrastructure would help a lot. Once a person gets sure about the the cheaper electricity on sustainable basis with the denser infrastructure, then it can give a very good pull to that one. So, but mobility needs are different, and charging is a technological issue. Of course, that's a resolvable. And then next challenge on range side, the previous presentations has already spoken that the swap option, and of course the moving ahead, the technology is improving in terms of the batteries and all together. So I'm not pessimistic on that side. Managing, and we have how we can manage all that peak time, like battery swapping. We said charging stations, there must have been the buffer storage. Speaker have spoken a lot on that one previously, so I will not consume more on that one side. And then broader regulatory frame must be flexible to generate the timely price signal and implement the dynamic pricing regime. And CTBCM implementation is a great hope, like we spoke. This is the CTBCM is the contract bilateral contract mode, means electricity market that is going into the competition. When it is going to competition, we have the lower price and denser infrastructure that we spoke already. So also we can leverage the from the CPAC, we can leverage, since all 4 provinces zones has been declared, like from starting from the Baltistan to the Sindh in the Dabeji in all together. All these are the 19 zones, and there have been the deployments, and then special incentives are already there. People are planning, and then others. This is a big opportunity, and then investor may plan for such areas. There, the EVs can be, industries can be established, and then for the desired growth. Generous, since for these industrial zones, generous incentive package has been given by the government already. One-time custom duties exemption on the plant and machinery, income tax exemption for the 5 to 10 years, gas, electricity, and other utility provided in the zone, captive power generation option is allowed for these zones. You can have your own plant installed for meeting the your own consumption. Even from the new NEPRA amended act, you can have a power plant there. You can captive power plant. You can give directly, a generator can directly give to other bulk power consumers from that one, because the market, there are no more exclusivities moving forward to 2021. So and then accessibility to major highways, motorways, and triports and airports. Accessibility is no issue. Tax exemptions, and then you have the all utilities availability, and that would be a good opportunity if that kind of industry is well planned and motivated, and then deployed into these zones. Henceforth, the cost is the cost perceptions of the capex cost and altogether that can be addressed from that one. So the green loop of EVs, the short term, currently we are into the short term loop, like you have an EV, may you have an increased consumption of electricity, but it is not going to address your issue, because at the back side you are basically having the electricity from the thermal. Remember that the 1 kilowatt hour of 1 unit of electricity used in a charging, at the background, if it is the energy is coming from the coal plant, it is 0.7 kg of CO2. And then if it is coming from the gas, it is let's say 0.3 or 0.2 kg of a CO2. If it is coming from the oil, it is 0.4. So we have to, this is the blue is the short-term loop. So we have to switch to the long-term. Let's say, for example, you may have the EVs, and you may have the infrastructure storage infrastructures via the lithium-ion batteries, and then improved viability of the renewables. And renewable are already the cheaper enough, because the recent tariff in Pakistan for the renewable is 3.72 cents into the solar, and then 4.7 into the wind. So hence we have the good opportunity. Even the renewables can play a wider and wiser role in the development of that. And then cheap renewables you have, and then that's what we have to look for in the long term for that green cycle of the EV. So thank you very much for